Hey everyone, welcome back to the channel. So this is the part 3 of our DevOps series, and in this part we are going to mostly cover Kubernetes intermediate concepts. So before I will discuss that what are the things we are going to cover in this particular part and what are the topics that we will be covering in the next parts, I want all of you to listen for the next 2 to 3 minutes. It's very important. Now I have been working on one particular topic for a long time, but I haven't announced, so most of you actually don't know, and that is, if you know that this is my English channel and I also have another Hindi channel, but I have a very important announcement and I'm pretty sure you all will be very excited and happy, and that is actually I created a new channel. Now before you might be thinking, okay, why this new channel? Now I'll give you an overview. So this channel will be mostly focusing on premium level content. Now what I mean by premium level content, now most of you know that in YouTube you will get lot of web dev channels. There are a lot of videos, but most of the videos are repetitive, and whenever you want any kind of premium content, so I'll give you one simple example. Let's say system design. So in that case, what you need to do, right, you need to pay quite a large amount of fee for a particular course, or let's say you need to buy a cohort or something like that, or you have to go to Udemy and you have to buy those courses, then only you'll be getting those kind of content. So what this channel will focus mostly on the premium level of content that you don't normally find on YouTube. And I really mean it. When I'm going to upload my first video, you all will understand what I'm talking about. Okay, so I want all of you, like I will say, like, please subscribe to this channel. You will not be disappointed. Now there is a criteria, and the criteria is because all the videos will be long in this particular channel, and there will be only one to two videos, I will say only one videos in 1 month, or mostly one videos in 2 months will come in this particular channel. Okay, and this will be completely premium, and I can guarantee you will not get this kind of content anywhere else. And the catch is, I'm only going to upload the first video once this channel will cross 5,000 subscribers. So that's why I highly recommend that if you want this kind of premium content, please subscribe, and also please share with your friends. So this is the first point. Second point, as you already know that I will be launching a full stack course in very minimal fee. The course date is not finalized yet, so I want all of you to visit my website. Go to sdevup.com/courses, this page, and see all the details, that what are the things that we are going to cover. Each and everything you're going to get in one course, so that you don't have to buy multiple cohort courses and spend a lot of money. And you can see that first 10,000 persons will get 50% discount once I launch this course. Currently there are 885 students are already they're actually waiting in the wait list. So I highly encourage, if in case you're interested, then please just join here. It's completely free. Now let's go back to the curriculum. So what we are going to cover in this part 3, and that is, we are going to cover the intermediate concepts of Kubernetes. So let's see in detail. So the first, if you following this particular series, this DevOps series, you'll see that we already covered DevOps part 1 and part 2. And if you're completely new, then I will highly recommend you have to first complete the part 1 and 2. Why? Because it's actually connected. If you directly come to this part 3, it will be very difficult for you to understand that what is going on. Also, all the notes and source code you'll be getting from my website. It's completely free. You can download from there. So first we'll start with this pre-section, where we are going to understand the Docker networking and Nginx. So we will be mostly focusing on container to container communication, okay, and how Nginx and reverse proxy works. And then we are going to apply all this in our MON application practically. Then we'll move to imperative. Imperative we have already covered in Kubernetes in the first part, but in this one we will be covering on declarative or YML files, how we are going to create YML files and all the core declarative objects in Kubernetes, okay, for example pods, replica sets, deployment services, etc. Then we'll move to the next section, where we are going to cover the resource management, namespaces, labels, and selectors. Okay, and then we'll be moving to another very important section, that is configuration. So we'll be learning how you can create ConfigMaps, secrets, how you can manage database URLs, passwords, and then how you're going to inject those kind of configs in your backend deployment. Once we'll cover all of these, then we'll move to very important concept in Kubernetes, that is Ingress, right? So that is the reason you see that we have covered the Docker networking and Nginx in the pre-section, because in the Ingress part, we are going to learn how we are going to implement Ingress using Nginx Ingress controller, right? And then we are going to apply all this in our Mon application as usual. And in the last section, we'll be covering storage and persistence. Okay, so this will be in the part 3. Now again, this is not yet completed, so this is only intermediate concepts you can consider in Kubernetes. Now what will be in the next part, right? So in the next part, we are going to cover Kubernetes scale, you can see resource and auto scaling, reliability and access control, Helm, and then we are also going to cover monitoring and logging. I'm deciding to cover EFK stacks, so that I will give all more details maybe in the next week. And then we also will be having part 5, part 6 and part 7, right? So in the part 5, we have a lot of things. We have Terraform, Ansible, Jenkins, advanced parts. We are going to cover vault management, artifact repository, and a lot of other things are there, right? Then we'll move to part 6. So you can see that we have monitoring, advanced, logging, stack, distributed tracing, security, lot of things. And at the end, we'll finish with GitOps and cloud native production. Now again, so one more important point is that the part 5, part 6 and part 7 curriculum can vary, so I'll update all of this in my channel community post. But for now, part 3, this is what we are going to cover, and part 4 will be covering these things that I mentioned. So this intro is very, very important, so I want all of you to understand that what we are doing, right? So that's all for the intro part. I will again repeat everyone to please subscribe to that new channel. It will be very I say you'll get a lot of advantage from that particular channel, I can guarantee. And you already know that how I teach from my Node.js series also in this channel, whatever is there, but there it will be much more advanced and premium quality content you will get. So without further wasting any more time, let's get started and good luck. So first, before we start with the first section, a couple of things I want to mention. First, if you are here for the first time, you need to complete part 1 and 2, and that is mandatory. Why it is very important? Because see, this series is actually connected for each and every part, right? So the way I've designed the curriculum, I've given a lot of thought process. So if you haven't done part 1, it will be difficult for you to understand part 2 and so on, right? And second thing, if you have already watched the part 1 but you are directly coming to part 3, again you have to complete part 2 first. Third point is that as I already mentioned in the intro, that we are going to cover like quite a few concepts of Kubernetes, but before that we need to cover this very small section, although this is very, very important. Now if you remember, in the part 2 we have discussed the concept of persistence, Docker volumes and networks, but in the networks I have mentioned one particular concept that we haven't discussed, and that is container to container communication. And I mentioned that in the part 3 or in the next part, whenever we are going to cover, we need to actually understand this part very, very clearly, because this is very, very important. And the same thing we are going to start with this particular section for this part 3. One more thing, as usual, we are going to use the exact same Mon application that we have used for part 1 and part 2. Okay, if you don't have this source code, this is available in my website for free, so you can go to the project section and you can download. Now let's do like this, right? So we'll follow the same structure. So we'll go here and we are going to understand a couple of concepts, and then we are going to apply those concepts in our Mon application. And I believe that will be again the best way to learn all these concepts, because these concepts are very, very important and you actually can't ignore and directly jump to the practical, right? I already mentioned in the part 1 and part 2. So DevOps is kind of a I will say like ecosystem, right? So where lot of concepts are there, and if you go to any other YouTube videos or any other courses, you'll see that tutors are covering a lot of concepts, not just directly applying all this practically. So what I will do, as usual, let's take a box here and let's change this one to maybe let's try some different color this time. Okay, maybe this one, and then I'm going to keep this one, or let's change to this. Okay, fine. So first, what we need to understand, what is container to container communication and why we need Nginx. The first of all, see, I have already discussed multiple times the concept of container, why we need persistence, what is volume, and also what is networks, how you can create networks, how actually networking works if you are not doing container to container communication. Instead, you are talking in your local host, right, with your host. But when I'm talking about networking, first we need to understand, again, let's start with what is container, right? I will start with that only because I'm going to repeat a couple of things multiple times. So what is container, right? See, container is an isolated environment, and I mentioned this on multiple times. So this will be isolated environment, right? Let's make this on bold. Okay, so container is actually isolated environment where you have its own file system, own process, own networking stack, right? So if I explain this one in terms of analogy, so you think container is like, I already mentioned this point also, apartment in a same building. This is the best example I can give. So let's say you have a building and you have multiple apartments, and each and every apartment is like your containers, right? So that means if you go to a particular apartment, what you will get? So you'll get this apartment will have a bedroom, it will have a corridor, it will have a kitchen, something like that, right? So you think like that. So a container will have its own file system, processes, and networking, right? Now what will happen, let's say I have a apartment A, or let's do this one with container. Let's not do, so let's say I have a container A and then I have a container B. Okay, what will happen, right? So this container A, or let's consider this one with the context of apartment. So let's say you have an apartment, and for a particular apartment you have a mailbox. For apartment B also you have a mailbox, right? But for the A apartment, it doesn't receive the letters for the other apartment, for B apartment. I hope you're getting how I'm actually explaining this. That means when you have a multiple containers, container A actually doesn't see the container B processes or ports unless there is a link between that. Okay, so there should be some link between these two containers, or else these containers doesn't know each other, right? That what processes, what file system this container A, so container A doesn't know about container B, container B doesn't know about container A, right? So there has to be some kind of shared hallway, or we talk that one, we can say this one in terms of DevOps, that is called as network. So there has to be some network between both the containers, so that container A can talk to container B, something like that. Okay, now when we are talking about localhost, now here we have to understand a couple of things, right? So let's say I'm talking about localhost. Now see, when you're working with localhost, right? So outside the container, look, what is mean by your localhost? These concepts are very important, right? So localhost is nothing but your host machine, right? Inside container, what localhost means? Localhost means this container only. Now again, I know this will become little tricky. So what I mean, let's say I have a container A. Okay, let's explain this way. So let's say I have a container A. Now this container A has a let's give this on a circle, something like this. So let's say I have a circle, right? And okay, I'll put this on below. So layers. Oh, let's remove this. Okay, we'll do this on this is taking time. So I'm going to remove this. So I'll take like this. So let's take here, and for this one I'm going to make this one as white, and let's do this one as container A. I know you might be thinking why I'm taking a lot of time. There is a reason. So let's say you have a container A. Now this is your container place, right, where you have all the file system and everything. Now outside this container, so outside this container, what is actually your localhost? Your localhost outside this container is actually your host machine, because your localhost is in your host machine. But when I'm talking about localhost inside the container, this localhost actually means this container only. So this doesn't know about outside. I hope you're getting what I'm trying to explain here. So that's why when, let's say if I just give one best example here to simplify this on better way. So now that is the reason when we'll do, let's say I'll write here, right? So when Okay, let's keep this on side. This is very irritating. Let's keep here. So let's say when I'll do right something like curl localhost 5000. So what this means here, actually this hits the backend. The reason, because if you go here actually I've given this port in my Docker Compose, right? And from my front end container, this, when you call from inside from the container, front end container, this will fail. Why? Because there is no backend process inside front end container. I hope you're getting. I'm talking about container to container communication. So inside container, your container doesn't know about what is this localhost 5000 is. Okay, so that is the reason we need some kind of bridge between two containers or multiple containers so that they can talk to each other by what? By the container name. Okay, so by the container name. Now we'll also understand how we are going to call that one by the container name, but before that let's understand some of the basic things. So I think this I've already discussed, that how many kind of Docker networking is there. So you have a bridge network, then you have a user defined network. I think I've already discussed this one, right? So bridge network will be by default, so where container will get isolated private IPs, right? And they can't talk to each other by their name, right? So this is the thing. So that is the reason, if you notice, till the part 2 we have used localhost, because that is actually your host to container communication, not container to container communication. I hope you're getting the point now, because inside the container, your container doesn't know what is your localhost is out from the outside, because from the outside it's a localhost is nothing but your host machine, but inside container it only know that container, it doesn't know other containers. Okay, so this bridge network, whatever we have used, so bridge network not used means this is the default network. So this is a default network. So here what will happen, right? So here actually every container will get IPs and they can't talk to each other by their name. So let's say I have a container C and I want to call this container D. So normally till now what we are doing, we are using localhost and talking to front end and back end. But when we will establish a container to container communication, instead of doing localhost, what we'll do, right? We're going to call that container by the name. So container D will call container C will call container D by the name. Similarly, container D will call the container C by the name. So name is nothing but this container name here. Okay. And then we have a user defined bridge, like when we are going to create, user will create the bridge by themselves, right? And here what will happen, right? Whenever you are going to do that, so container can talk to each other by the service name. So that we are going to see how it will work. Now what is the advantages? Now again, important interview questions, you can also note it down. So advantages of container to container networking. The first of all, service discovery. So you can note these down, right? I've given a lot of effort while finding this term, right? I read all of this in blogs, official documentation, and then only I came to like conclusion that how I'm going to teach, right? So when I'm explaining all of this, you don't think I'm just wasting your time, okay, that I'm talking too much. These things are very, very important. You go to any DevOps interview, you'll see that when they will go into much depth, let's say you're going for any product based company, they will go to this container to container communication, the small things very, very seriously, right? You need to understand these concepts. So what is service discovery? Means IP can change, right? So IP usually change every run, but names will not change. Means container C will remains container C always, container D will remains container D always, right? And this is exactly what we are going to learn in the Kubernetes, right? So service discovery is one of the most important advantage of container to container networking. Security is extremely important. Extremely means I will say very, very important. Let's say you have a DB, right? And you don't want your DB to be exposed. So in that case, what you can do, if we are doing container to container communication, no one from outside that network can ever exposed or get access to that particular Mongo. Third, I think you have also noticed this one if you're trying, right? Port collision means sometimes if you're using same port, it will collide with each other, and here it will never, because they are isolated, right? We are calling the containers by their name. And scalability means even we add multiple backends, we can still, or they all sit behind the container name. So here let's I'll give this one as backend, so it will always call as backend 5000. So backend is nothing but the container name. So this we are going to see. Okay, So now I hope you got the advantages. Now we need to understand that what was the flow that we have covered till now and how we are going to do now. So here we are going to introduce a very important concept, and I believe almost most of the big companies, you talk any companies, they uses this particular technology, right? Technology or Nginx that we are going to cover topic. But before that, let's understand that how till now what we have done. So we have what we are doing. So we have the front end container, remember? So we have a front end container and we have a port 5173, and this was calling what? It was calling the localhost 5000. Now this is actually nothing, but it is actually pointing to itself, right? There is no container to container communication is happening here. It's actually talking to the host of that machine. But when we are going to do correct way, how we are going to do, right? So we'll do front end, which is our container name. It will call the backend container, and let's say this will call our Mongo container, okay? And there can be port also. Let's say you are calling on 5173 500. Mongo usually call 27017 local, but I'm talking about the container to container communication here. What will happen when Nginx comes into picture? But obviously we haven't discussed what is Nginx or reverse proxy is, but let's see the diagram very simple way so that it will be easy. So we usually call everything from our browser, right? So browser is going to call Nginx, which has a default port you consider as 80, and this is going to create a proxy to your backend and front end service, okay? So just learn this term, that's it. Then we are going to go into much depth. That we are going to go to browser, we'll call Nginx will serve at the default port, consider 80, and then it's going to reverse proxy to your backend and the front end, and we are going to exactly see how this will work. But I hope with this, I think this will be clear, right? That what is actually networking, what is the container to host network networking or communication that you have done so far, and why actually we need container to container communication, which is very important. And now in the next section we'll understand what is Nginx reverse proxy, right? And how you are going to apply that in the Mon application. So let's do that in the next part. Alright, so let's understand now why so what is Nginx and why actually we need Nginx. So first of all, let's start with the definition, right? So we'll do Nginx. So what actually Nginx is, right? So in a simple word, it's a web server and reverse proxy. So I'll give this one as it's a web server and reverse proxy, right? Now I'll give you one stats. You can also research on Google that almost more than, I think it's more than 30% websites, I'm talking about all the websites, right, actually uses Nginx. And how it is very helpful, right? This actually very scalable, and it can handle millions of concurrent connection, and that is very important, right? And what actually happened, that why actually we need the term, or why actually call the term reverse proxy, and that is, again, I'll explain this one very simple way. So proxy means, let's say when you are a client, so you are a user, so you'll go to browser, right? And let's say you submit a website URL on Google. So that means when your client or the user will thinks that it actually talking to a server, but what actually Nginx doing behind the scenes, right? So it will route that traffic to the correct service, right? So it is actually working as a reverse proxy, as simple as that. Why we need Nginx in Docker, right, or containerized setups? First of all, the main advantage will be to hide multiple services, right? So this will be one of the main advantages, where you are keeping everything behind one clean entry point. So here entry point is nothing but your Nginx. So Nginx is the entry point here, right? So I'll give here Nginx is the entry point here, right? So you are actually hiding all the multiple services and you are routing through Nginx, and it's Nginx job, it is going to talk to the correct service. All right, also it can help with path based routing, and there are a lot of other things. And there is a prerequisite, because we are going to discuss Kubernetes Ingress. So that is the reason we need this Nginx, because Ingress also in the hood or behind the hood uses Nginx, right? So that is the reason we need to learn this. This is mandatory. Now see, there are two things you need to understand. One very important, like I'll not say interview, but sometimes you can get, that is, what is the difference between that forward proxy and reverse proxy, right? Because we are talking about the term reverse proxy. So an interviewer can ask you, okay, you mentioned the term reverse proxy, so what is the difference between a reverse and a forward proxy, right? Now see, when we are talking about a forward, so forward proxy, so how it will work, so we are simply going to client is actually doing what it is doing, let's say using a proxy, and this proxy is calling nothing but the internet, right? So let's say you're using some you are working on any company, and you'll see that most of the companies uses VPN or proxy, something like that. Reverse proxy is, so here what you're doing, so you have your client, then you have your proxy, and this proxy is talking to what? It is talking to private services. Okay, so this is the difference. That means this will protect, and this is going to simplify access. Now why simplify? Because I already mentioned that this will help us to hide multiple services behind one entry point. Now if you talk about real world example, right, I think Netflix also uses something like Envoy. I don't know how to pronounce that, so you can search Netflix Envoy. I think they uses this, right? So this they uses for the service to service communication. You can search also, right? Then GitHub also serves static files with Nginx, and there is list is endless. Lot of examples that you will get. Now when I'm talking about that how this Nginx will fit in our Mon application, because we also need to understand, right, we are going to apply in our Mon application. So what will happen without Nginx and with Nginx? So let's say without Nginx, what will happen? So you have your front end, and your front end is doing what? Localhost 5173, correct? And then you have a backend is doing what? So you have localhost 5000, right? So this is your front end and back end, and you're talking to your front end, you're calling your back end, and you're doing whatever things you want to do. With Nginx, how it will change, right? This is also very important, and that is with Nginx, both these front end, now remember I already mentioned this, multiple services, so both this front end and back end will do what? It will both behind, it will be behind, so I'll give both will be behind your localhost. So let's, I'll give HTTP, and this will go behind your localhost, something like that, right? And then you're going to simply hit this localhost. In the back end, what will happen? The slash will goes to front end, and then I have, let's say, API endpoint, this will goes to backend, and we will handle that. This will be handled by Nginx, right? So that means Nginx is routing the correct services, or its point to correct services, but in the client side you are just going to hit this or browser, from the browser you're going to hit this localhost, and then it will with slash it will go to front end. And now again, definitely this is going based on the configuration that we are going to give, but behind the hood this is how it will work. Okay, so now what you're going to do, right, so we need to create a Nginx configuration, and then we are also going to change our Docker Compose some of the things, because now instead of calling our host, we are going to do what? We are going to do container to container communication, right? So one container will communicate with another container, and we are going to use Nginx. Nginx will be responsible for routing the services to the correct service. So let's do that in the next part. Alright, so now let's see how we are going to create the Nginx config, right? And also this one will be very simple, but I'm going to explain each and every line that what actually we are doing here. So to do that, the first of all we need to go here, okay, and at the top or at the root create a folder and give this a name as Nginx, and inside this we are going to create a config file. So I'm going to do Nginx dot, and this will be config. That's it. Now here we are going to write all the proxy, that how we are going to call our front end, how we are going to call our back end, how it will actually do the routing. So Nginx is actually responsible for all this, right? We have discussed in the previous section. So let's start with the first one. So what actually, okay, first what this file will do at the top level. So this will this is a simple, okay, let's give a comment. So this will be a simple reverse proxy, right? And this is a config for our marnap. What this will do, this is going to serve, not server, serve. This is going to serve front end, or in this case, because we are using Vite, so it will be Vite preview, or it's going to build our assets at where homepage, or like slash is nothing but this is where it is going to call or serve our front end. And this is going to do a proxy, right? So proxies slash API, and here it's very important, slash star means any route starts with slash API, and this is going to proxies to where, to backend service. Remember, I already mentioned that Nginx is like a front man, and at the behind you have multiple services, and Nginx is going to handle, and it will automatically decide that I need to call which, or I need to do proxy to which service at a given point. And here also I'm going to set some headers, okay, so that your backend, so I'll do so that your backend, okay, how to explain, so backend can see the original host and the client IP from where actually user is doing the request. So this will be the overall idea of this. So first of all, what we need to do, right, we need to start with a top level blocks. So here we'll start with the events, right? So what these events, so this is actually a mandatory, or not mandatory, means this Nginx requires this block. So here it will tell that how Nginx is going to handle your connections, because we don't need any extra tuning here, so we are going to leave this one as black. Okay, if you want to know more about this, you can go to the Nginx documentation, and you can also read all of these. There are a lot of things, right? And the documentation is huge, right? There is a single module, and for every, for example, let's see, if you go to HTTP module, you will see hundreds of properties and everything. So let's start with a very simple one. So after this, what we need, right? So we need a HTTP. Now what this HTTP or this block will do, so this is going to tell Nginx that how we are going to handle our HTTP web request. So what HTTP web request is nothing but our website traffic, right? When we are going to call our localhost from our browser, so this block will tell that, okay, now we need to handle our web request, and all your web server logic or config or rules, I will say rules, it will go inside it. Okay, so this will be like this. So HTTP, and here what I'm going to do, simply I added a extra property here. I think I also have added all of this here so that we can save some time. So we'll start with this client max body size, and what this is actually doing, so this will simply tell Nginx to limit the uploads size, right? So this is for that. So for example, let's say if I want to give here, so this will tell us that increase client body size if you want to test, if you want to test big payloads, right? This is optional. Next, what we are going to do now, here we are going to have the main important part, or the server part, right? So each and every block, for example, HTTP block, events, config that, or block that we have added, server block, all of these are detailed mentioned in the documentation also. So what this server block will do, so this block is nothing but it's like a virtual website, right? So here what we are going to do, we are going to tell that Nginx will listen to a particular port. So by default it will listen to port 80, right? So that the same thing we are going to give here. So I'm going to give here listen to 80 port. So what we are simply telling that you are going to listen for all the requests in this particular port, right? So this is another thing. Next comes the very important part, right? So here we are going to now write our location. Now what this location will do, right? So for example, we have for now front end and back end, right? So front end will serve at route this slash, and backend will serve at our proxy to slash API route. Now what we are going to do, right? So we need to create two location. So first of all, here after this I'm going to add a location, and I'm going to tell that in which location this block will run, right? So this block will serve. So this will be slash, because this is the location where we are going to serve our front-end app or the Vite app. Okay, now inside this we are going to add a couple of things. The first of all, we need to add a proxy pass. Now what actually we are doing here, very important. First of all, this is the location. That means when any user is going to visit the home page, so this is the home page, right? This is the slash, mean it's the home page, or any non-API route. So what will happen, all the request, it will it is going to send the request to the front-end service. So that means if I just give a comment here, simple way, that when someone visits slash, or I'll give this one as home page, so what I'll do, right, it will going to send the request to front-end service. But how it is going to save, right? So for this one we have another property, and that is called proxy underscore pass. So how it will happen, so it's going to proxy to HTTP, and here what will happen, let's say we want to go to front end, and here I'll give this one as :5173. So what this is doing here, simply this is, now again remember one very important point. Now see, we are not giving localhost here, this is the front end. So what actually this is the container name that we have, right, in our Docker Compose file. If you see, I'm not sure if we have that, so you can see that we have the container file here, the container name here, which is front end, right? So simply we are just proxying this to this particular URL. Now after this we are going to add some more properties here. So let's copy this and let's paste it here. Okay, so first of all, what we are doing, we are simply, see, proxy set header is nothing but this is going to preserve the original host header. Okay, next we are having the X real IP, so this is going to provide the real client IP to the backend, right? And this is going to pass via header. What will happen if you don't pass this one, right? So this Nginx, it's not going to get the original IP. So not Nginx, sorry, my bad, the backend is not going to get the original visitor real IP address. So backend will just see the Nginx internal IP. So that is the reason we need to send this X real IP. Okay, then we are having the X forwarded proto. So what this will do, this is going to forward the original request protocol, so it can be HTTP or HTTPS. Okay, and then we have another property that is called proxy buffering, which we are keeping off. That means it's going to avoid any kind of buffering for dev, so that whenever we have any kind of logs, the logs can appear immediately. Alright, so this will be for the particular location. So this is from where our front end will be getting served. Now we need to create one more location which will be for our backend. So now we'll do one more location here. Now remember, this will now go to the slash API. Now remember how these all are connected, right? So whenever we'll go to or proxy to any slash API or starts with slash API, that means we are forwarding the request to the backend service. Now here what we are going to do, simply again we are going to do a proxy pass. And where it will proxy pass, so HTTP, and here I'm going to do backend. Now remember, this is the container name, and this will be :5000. Okay, then let's copy from here the rest of the things. So we have the same thing, the header. So we have the header real IP for forwarded proto, and then I've added some timeout related, right, in case the backend person is taking longer, so we are increasing the timeout. Now here you can also add one optional property, and that is you can also add a health check. So I just added here, so you can just copy this one, and this is optional, so you can add this one here. So after this, okay, so now this will be a very simple configuration that we need, right? So we discuss each and everything. Main important point, you need to understand that how this location is going to handle all this, right? So whenever we are going to visit this, it's going to send request to the front end service. Whenever we will call slash API, starts with any slash API route, it's going to do a proxy to the backend service. And how it will call, if you notice that it is going to call with the container name. So front end is the container name for our front end, and backend is the container name for our backend. Now this is done. Now is this completed? Not yet, because now we need to change some configs or some configuration in our Docker Compose. I have also added here. So let's first see what are the things or changes we need. Now first let's start with the services. So we already have the Mongo service, image will remain same, then we have the container name, restart, and then we have the volumes. And networks, these will be same. Now remember, in the part 2 only I have created the net network. If you don't have any network, you can create. If you have given a different name, use that particular name. Okay, now for backend, let's go line by line. So we have the build context, this will be same. Docker file, this will be same. Container name, this will be backend. Restart, this will be unless stopped. env file, this will pick from go to server directory env file. And here you can see that we have ports. Now remember, here actually this is for your testing purpose. You can keep this one for debugging, but actually Nginx will handle this, right? You don't have to keep it. So if you see in the here, I have actually removed this one. You see we don't have the port here. So what we can do, we can simply delete this. Okay, and depends on Mongo networks is MAN. Similarly, you see in the front end it will be same. So you have the build from context is from the client directory, docker file is docker file. Now here we have the args. Now what we need to do, right, instead of this localhost 5000, what we need to do, we just need to keep it /API. Now why? Because we have already we are using Nginx, which will do the proxy, right? And if you see, I think I've added the same here, right? So let's go here. You can see we have the /API. Container name will be same. Restart, leave it. Ports we're going to remove, we don't need. Depends on, keep it. Network, mannet. Now here next, very important, we need to add for Nginx. So I'm going to just copy this from here, and then I'm going to just give enter and paste it. Okay, we need to keep the indentation correct, right? So I'll just, okay. Now you can see in the Nginx we have the image. This is the container name, same. Restart, this is where the volumes will be stored. Port, very important, 80. We have already told, I already explained this one. So this is the default port that we are going to use. It depends on front end and back end, same. Networks, this is the same network, all will be in the same network. Remember this concept we have discussed, that whenever you have multiple containers, there has to be some link so that they can connect to each other, right? So we have the same network but multiple containers. Then at the end we have the volumes and network, keep it same. And now this is done. Okay, so now what we have achieved, so we have achieved a container to container communication with combination with reverse proxy. So now to run this, what we are going to do simply, so we'll simply just do docker compose up build, right? Now let's see what is happening here. And if I, let's see if I have anything here. I think I already have some, so let me just delete this one. Okay, let's go to images. I think I have created a lot of, let's remove all this. Mongo Nginx set, let's keep, or else again it will pull, right? It is going to take some time. Okay, I think this is fine. So now let's go here, and then we are going to do docker compose, and we're going to do up build, enter. Okay, so now let's go here, and you see, right, let's go to this port first and see what is happening here. So this is running on localhost, as I already mentioned. So whenever you will go to the /route means homepage route, right? Some people don't get it, that what I'm telling here. So this is what I mean. So when you go to this route, right, homepage, so this is actually doing the proxy. This is happening behind the hood, and Nginx is actually handling this. And if I refresh this page, and you can see that what it is calling, http localhost /API/task. Very important. And you can now add a new task here, and this will work, right? Awesome. So now I think we have covered this. This is a very important concept, right? That whatever we have learned so far. So we have learned that what is actually container to container communication, why we need that, what is the advantage. This part is very important, right? What is the advantage? Service discovery, security, port collision, scalability, all this. What is Nginx, reverse proxy, and how we are going to implement. Now again, I will say definitely this is not completed. Nginx is a very vast topic. You just go to the documentation once and see how many things are there. Even I don't know all the things, right? I have to research, I have to read, and based on that I have to do. What I want from all of you is that first you complete this, do the practical, and if you have time, then you can explore the official documentation, right? So that's all about the first particular section. Why we have also done this one, because when we are going to implement the Kubernetes, so that time we also need the concept of Nginx, right? So that is the reason this is a prerequisite. With this, I think we have also completed the Docker intermediate section, right? Because I already mentioned that we are going to end with this Docker intermediate in the next part. Once we'll complete the container to container communication, and then we'll see in the next part if we have some advanced concept that I can cover. But with this part is completed. Now let's move on to the next one. Alright, so now welcome to the new section. Now if you notice that in the part 1 we have covered the basics of Kubernetes, how Kubernetes works, some of the concepts of pods, then we have deployments, services, and those kind of things. Now if you remember, in the part 1 I already mentioned that we are only covering imperative way of writing Kubernetes, right? So now in that section we haven't covered the actual the standard way of writing Kubernetes, that is called declarative, or how we are going to write YML file, and in a structural way we are going to run and deploy our app using Kubernetes. So the same thing we are going to do in next like 1 or 2 hours. Now I want to mention one more important point here, and that is this is not all the concepts that we are going to cover in this whole DevOps series. So this will be only, you can consider this one as a basic to intermediate level, because in Kubernetes there are a lot of advanced level of concepts are there. So that will be coming on the next part, okay, not in this one. Now again, that will take some time, but definitely the part 4 and 5 will be uploaded. So I just wanted to give a heads up. So now if you notice, in the previous section we have already covered the Nginx, then we have also discussed the concept of container to container communication, right? So we are going to use the same application. So now let's get started. The first thing that why actually we need to write in a declarative way. Now see, now let's take one more here, okay? So I'll copy paste this one here, and let's remove all this. Now what is the core idea? Now normally what we usually write when we are talking about declarative, that we usually write a YML file, and this file will have all the steps. Now when I'm talking about steps, I'm actually trying to explain this one in a simpler way. Step means, let's say you have a step 1, step 2, step 3, step 4. You are simply telling that, okay, I want to run all these steps in this particular order, and it is going to do the job for me. Instead, previously what we have done, we are doing all the commands step by step, right? Let's say I want to do kubectl, then I'll do create pod, so it will create a pod. Then I want to do, let's say for example, kubectl, you create a deployment. So this is what actually we have done in the first part. So this is like imperative way of writing, right? We are doing each and everything. Now this is definitely time consuming, and also now I will say like this is also important to understand, right? So that is the reason I've discussed in the part 1. Now why I'm repeating this thing again, because if you think that okay, declarative is the only way of learning Kubernetes, that is very wrong. You need to learn all this, like whatever we have covered in the part 1, that is extremely important, and I will say that is the prerequisite. That is the reason from imperative to we are moving to declarative. Now why the declarative is a standard, right? Now first let's understand what actually is declarative. So declarative, if I explain in a definition wise, so it will be, you are simply describing what the desired state, that this is what I need, and then what will happen, so you are going to store this state, right? So this desired state in form of YML file. So I'm just giving YML as an example, and then what we are going to do is simply to, let's say, run kubectl apply and whatever command you are running here. So simply what you are doing, so Kubernetes controllers is going to operate, right, to reconcile this desired state that you need. Now why then what is the advantage or why this is standard? The first of all is when we are going to reapply the same manifest result in the same cluster state, I'll not say same cluster but same cluster state, what will happen? There can be very less or almost no unexpected side effects. Second thing, when you're going to write YML in Git, that means you're doing simply infra as a code. So you can do what? Review, you can raise PR, you can revert the changes, and also very, very important when you're working in a very top or product based company, you can trace who changed this one. See, normally I'll give you one very interesting fact. Not fact, like this is what will happen, right? So if you are a student or you don't know how actually these things work, so normally in projects like that I actually worked, so we have YML file like Kubernetes YML files that we have written in our repo, right? So now every time, let's say we are going to change anything in this file in maybe dev environment, stage environment, prod environment, there will be always there will be a notification that will be triggered, for example, to by Slack. I'm just giving one example, right? It can be any tool, and then we can easily track that, okay, which developer changed what and in which environment. I hope you are getting right. So this is very, very important in versioning also. Next, I'll give you one more point here, and that is called drift detection and self-healing. So this is also another advantage. So what actually we're doing, so here what happened, right? So controllers will continuously reconcile your drift. Means if, let's say, a node kills a pod, so there will be a replica that's going to recreates that another pod. Okay, so we are going to learn the concept of replica and what is pod. I think we have already covered, so you'll understand what is replica is. Then testing, for testing also it is helpful, right? So you can do lint, you can dry run, you can also validate the manifest, right? You can also promote the same manifest to multiple environments, right? This point also I mentioned. Let's say you have a same manifest and you want to promote this one to your dev, stage, prod, pre-prod, all those environments. And another extremely important point here is scalability. Now why? Because when you are working on a very big ops team, right? When you are working in a very big ops team, there you have hundreds of clusters, right? So hundred of clusters or environment you can be easily managed through this declarative code or declarative way of writing. So these all are will be main reason that declarative is a standard way of writing. Now before we move directly into writing all these concepts, we need to understand, or I will simply recap some of the concepts that we have covered in the part 1 in case you have missed it. So first, if you remember, we have discussed some core objects that Kubernetes has, right? So first one is pod. Then we are going to cover replica set and deployment. Deployment and pod, I remember I already covered. So what is actually pod, right? Or pods. So pod is the smallest deployable unit. Very, very important. So just remember, this is the smallest deployable unit. Okay, this will be the best example of a pod. Now here one important point is that if a pod dies, so unless there will be a controller, right? So there is a controller that recreates the pod, what will happen? It remain terminated. So unless you create it. Okay, next we have a new concept. I think I haven't covered this one, that is called the replica set. Now what is replica set, right? So replica set will ensures that there is always n replicas of a particular or of a pod run. So what I mean, so here it is extremely important, if a pod dies or crashes, let's do crashes, what will happen? Replica set will create a new one. I hope you're getting right. Now here we are going to understand some of the resource management concepts, like what is label, what is selectors, but just remember, I'll give you one term here. So it's actually uses label selector. That is the point that I wanted to explain, but let's discuss later. So these replica sets will use label selector to manage pods. Okay, now here what will happen, right? Usually these actually are auto created or managed by deployments, right? You don't have to like manually write or handwrite replica sets in prod, but it's always better to understand all these concepts. These are very important. Now consider, let's say you have a replica set. Okay, so let's do like this, and I'll give you a replica set, and then here I have a replicas 3. Okay, what will happen, right? So this actually nothing but here we have a pod running, let's say backend 1, then there is another pod running, pod backend 2, and then there is one more pod which is running as backend 3. Okay, now moving to the next one, I think this we have already covered, both deployment and service, but let's cover one more time. So see, what is deployment, right? In one word or in very simple sentence, this is the high level or higher level controller that manages what? That manages the replica sets. Okay, now these will provide rolling updates, rollbacks, revision history, lot other things. So for example, let's say I have a deployment called backend. So how this flow will work, right? So you will have a replica set. Let's say this is backend version 1. Now remember, this is very important. So you have a replica set version 1. These replica sets will now have pods. I hope you're getting the point. Now again, let's say you have one more replica set here, which is considered as backend 2 version 2, which is new. This will again have the pods. Okay, so this deployment will actually handle this replica set. So what will happen whenever there is, I think this was already covered, that whenever there is a pod crashes, this is going to create a new one, right? And services, what is services? So let's do this one. I think I have covered in depth what is services, how it will work in the part 1. So it's like a stable network endpoint, as simple as that. So it's a network endpoint, right? Mainly we called as endpoints. So this consists of DNS plus your cluster IP. Okay, what will happen? This is going to forward to pods. That's it. Now there are different types of services, like let's say you have a cluster IP which is internal, then you have a node port. I think we have already covered. Load balancer you have, then you have headless also, right? So how it will work, let's say you have a client which is your front end, which is going to call the service, which is backend, then you have your proxy, right? And then you have the endpoints of the pods, something like that in very high overview. So now see, 4 things you need to understand again and again. Go to the official documentation, learn all this in more depth. Here I am just giving you the direction that how you are going to learn. I hope you are getting. In a video, it's impossible to cover each and every Kubernetes. Kubernetes is like very complicated topic, right? It's not a simple one, and there is no way you can master Kubernetes in like 1 month. Not possible. If someone is telling, they're simply telling, like I'm telling you. It's need time, it's need lot of concepts. You need to understand internally how things are working, or else you'll see whoever covered the part 1, and you see if you haven't practiced from that way, from that time, you see some of the things will be like, okay, what is happening here, right? So you have to practice all these things. So learn pods, especially deployments, services, very important, replica set. Now let's start, right? So first we'll start with that how we are going to write YML file, and we are going to deploy our MON application declarative way. All right, the first thing, if you remember that we have actually run this minikube container with Docker driver, right? So if you don't have that one currently in your Docker desktop or whatever you're using, so you need to run this first, or else you will get that minikube is not present. So you have to run minikube start, and then you have to give a driver which will be Docker, because we are using Docker. Okay, this you need to run first. If you haven't run, if it's already running, then you can see my container is already up, so it's already running here. All right, so once this is run, so now how we are going to do that? So first thing, we'll go to our MON application, and I can see that we have created an engine. I think this we can close. The first thing, in the root here, we are going to create a folder. Okay, and let's give this, we'll give this a name as K8s. Now inside these, couple of things we need to create. Now these things are extremely important, what I'm going to cover now next 1 hour. the first thing here, we need to create a namespace file. So first let's create it and then we'll see what is happening here. So first I'm going to give 00 hyphen and let's give this one name as namespace. Okay, and then I'll give what? Remember, we need to give YML, right? Now first thing we need to understand what actually this namespace is. Now here comes one more important concept in Kubernetes, that is called resource management. So you can search in Google also. So what is resource management is, right? So let's go here. Now if I try to explain this one in simpler way, see how my desktop is very slow, right? I need to pause 100 times to do this recording, so it's not that much simple, guys. I need to buy a new laptop, I think. Okay, so now resource management I'll give. I'll not go into much details because there are a lot of other concepts. I need to also keep something for the next part also, right? So in one part I don't want to cover each and everything. So for now let's cover in the resource management what is namespaces and what is labels and selectors, because these things are we are going to use. Now see how I've designed this code. So you think that what is the time went behind creating this series? It's not simple, right? See, I'm not telling because I'm doing all of this. I give lot of times thinking that what are the things that we are going to cover in this particular video. I'm covering those concepts only, means I'm not giving you too much information or less information. For example, I'm going to cover namespaces and label selectors, so that is the reason we are covering this. When we are going to cover CPU, memory uses, those kind of things, you will see that in the next part automatically I'll cover those things. I hope you are getting. So like, comment and share with your friends. See, I want to cover, I usually don't say in middle, but I want all of you, I'm requesting all of you to share with all your friends so that I can complete 100k as soon as possible. Okay, now first thing, what is namespace, right? So you think that, see, normally your Kubernetes is what? So it's like your app is running inside a cluster. Remember I explained that. So you think your namespace is like a folders. So your namespaces are like what? It's like folders in your cluster, Okay, this is the best example. So means what happened, right? So let's say it will separate resources so that you have, let's say, dev environment, stage environment, prod environment, Teflon environment, pre-prod environment. Pre-prod means when you are going to deploy to prod, before that you are going to test something, that is called pre-prod, right? What happened, these namespaces are going to separate those resources so that you don't mix your dev, stage and prod. I'm just giving an example. Okay, so this is like a folder. You have folder A, folder B, folder C, something like that. Now we are going to use our namespace for this one also, but I just wanted to give the definition. Why we need that? First of all, naming conflict, so it's help us to avoid naming conflict. Then it's going to apply some policies, right? Also, I think people always neglect this is also very important point. It's also easier to clean up, right? So for example, let's say I have lot of resources under one certain namespace and I want to delete everything. So what I'll do, I'll delete that particular namespace, which is going to remove all the demo resources or resources that I have. So it's like you have some files inside your folder, you're deleting the folder, it is going to delete, right? Next you have labels, right? So you have labels and selectors, So this is like simple your key value pairs, right? It's going to help you to tag on some certain resources. Labels, selectors are like queries, right? So selectors are queries that uses labels to find the resources. So labels are, so it's like simple key value tags, key value that tags you. Let's give tags on resources. Let's give this one sort. Okay, and then selectors will be the queries that uses labels to find those resources. So remember these two things. So now what we'll do, right? So we'll start with creating our first namespace. Now here actually I already have created all this here so that we don't have to write, but because there will be some sometimes some syntax error also, or some different kind of YML error you can get, right? So it will save some time. So what we'll do, right, so let's write all this first and then I will explain, and then I'm going to just format it properly, so it will save some time. So first let's start with namespace. So what we're going to do, right, first, so let's give a API version first, and I'm going to explain each and everything what you're doing, or else if you're doing for the first time this will be little tricky. So this is my API version, then I have a kind. So kind, I'm going to give this one as namespace. So I'm going to do namespace. Then I'm going to have a metadata here. So this metadata is what? So it's going to give a name, and here I'm going to give this one as DevOps. Let's give DevOps part 3. Makes sense, right? So do DevOps part 3. Now save this. So we have an API version, we have a kind, we have a metadata. Now what is actually these things are doing? The first one, API version, is actually tells us that which API group or version these resources uses, right? Second, we have the kind. Kind is simply the resource type, right? So what this is simply telling that, okay, this will tell Kubernetes that you need to create a namespace object. So this is here, that is the reason we have given here namespace. So this will tells us that, okay, for this one you create a namespace. Metadata, as you can see, it is very simple. It's simply the block that will help us to identify the object, right? So here we are simply giving that, okay, create a namespace with the name of DevOps part 3. I hope this is clear. This is very simple. So now let's go here, and then I'm going to just copy. I think we don't have, I think for this one is fine. Let's save this. So for namespace, this is the simplest config that we need. Now next thing what we need to do, right, now we are going to create some more YML file. The first one will be for Mongo, then we are going to create for backend, and then we are going to create for frontend. Okay, so let's start with Mongo first. So now what I'm going to do, simply let's give a 01, okay, hyphen, let's give Mongo only, and then I'm going to give YML. Okay, now here we need to write quite a few things. Let's start step by step. First I'm going to do API version. So here I'm going to give what? Now here you can see what I've given. We've given version 1. So I'm going to give this one as app/version 1. After this I'm going to give what? So kind. Now can you guess what will be the kind here? I think the reason why I'm asking, because in the part 1 when we have done step by step, we have actually created all this. See here, instead of namespace, the kind will be deployment, because we are creating a deployment. Okay, now next thing we are going to give a metadata. Now in this metadata, so let's give a name first. So I'm going to give a name. So this will be Mongo, and I'll explain what is happening here. Now I'm going to give a namespace. So what will be namespace? Remember, namespace is the folder, so this will be inside this namespace. So I'm going to copy this, paste it here. Then I'm going to give a labels. Remember, labels I mentioned already, how this all things are linked. So here I'm going to give, let's give this one as apps. App. This will be Mongo. Okay, now after this what I'm going to do, simply, so let's give some spec now. So I'm going to give a spec here, and here I'm going to give a replicas. Now again I'm going to explain all of this. Give me just some time so that we can, so at least half I will write and then we'll explain what is happening instead of writing all. So this will be replicas, and I'm going to give this one as 1. Okay, here I'm going to give the selector. Remember what selector will help, right? It will help us to identifying the resources we have discussed just now. So in this selector, what I'm going to do, right, we need to give this match labels, and here I'm going to give what? So I'll give here app, and I'm going to give this one as Mongo. Okay, so first let's discuss till this part, that what actually happening here. So the first one, as you can see, so simply we are telling that these deployments are in the apps/version 1 API group. So this is the group/version. This is the group/version. Okay, kind, I don't have to explain. So this is simply creating a deployment. Metadata is the object, right? So here we're simply telling that this is the resource name, which is Mongo, right? So resource name for this deployment, because we are creating a deployment. So this is the resource name. This is under the DevOps part 3 namespace. Remember, labels. What is labels? Labels are key and value pairs. Why we need that? To tag or identify the resources. So this is your resources. So this is the tag that, okay, this is for this particular resources, which is Mongo. I hope this is clear, right? Now what is spec? Spec is the desired state spec for this particular deployment. If you remember, I already mentioned that deployment is the one who will handle the replica sets, and replica sets is going to create pods in case if any pods crashes. Remember how these things are related. I told you already that we don't have to manually or human like write replica sets. Deployment is going to take care of all this, right? So this spec is nothing but this is the desired state that we need, or desired state spec that we need for the deployment. Replicas we have given only one, so this is the number of pods replicas. Then we have the selector. Selector is simply that how the deployment is going to identify which pods it manages. Okay, and here we have given the name, so simply this is matches with the pods that labeled as Mongo, right? So here we have the labels as Mongo. Now next what we'll take, right? So we are going to take a template. So I'll do here template, and for template we will also need a metadata. So we'll do a metadata here, and inside this I'm going to take labels. So we'll do labels, and here what will be the label? So the label will be app will be Mongo. Okay, so first I'll write once again all the rest of the things, then we'll explain what is happening here. So then we have metadata, labels, and app is the Mongo. Next we are going to take a spec. So here in this spec we are going to take the containers. So I'm going to take a containers, and here what we are going to do, right? So we're going to give a name. So the name will be the name of the container, which will be Mongo. Then we are going to take the image. So image will be the official image of Mongo, which will be Mongo 6.0. And here I'm going to pass the ports. So in the ports what we'll do, right, we are going to use container port. So the port normally runs on 27017. Okay, and here also after this I'm going to take a volume mounts, and here I'm going to take a name. So let's take this one as Mongo data, and here I'm going to also take a mount path. So here I'm going to do /data/db. Okay, so now let's see what is happening here, right? So first I think we have covered till selectors part, right? Selectors. Now then you can see that we are having the template. So what is template? So this is simply the pod template, right? So this is the spec that actually use to create the pods, as simple as that. Then we are having the containers. I think very easy to understand. This is the list of containers that will be inside the pod, and here in this case we have only one container, which is for MongoDB. This is the name, which is the container name here. This is the image, the Mongo image. Then we are going to have the ports, right? So we are going to run on the 27017, which is the port here. Then we have the volume mounts. So this is the volume we are going to use, and this will be where this is the path where the volume will be saved. Okay, so this is done. Now after this what we are going to do, right? See now remember one more thing here. So if you notice that this is the volume mounts, so this will mount volumes into the container file system, and this is the name. Then we also have the pod label volumes, so that we are going to take. So just to give the difference between two, volume mounts, actually the mount, it will mount the volumes into the container file system, means this is actually your Mongo data, right? Then you have the pod level volumes also. So once we'll do that, so let's do one thing. I think it's taking a lot of time, so I'm just going to copy from here and then we'll explain. So I just have this one here. This is the exact same thing, so I'll just copy from here and then we'll paste it here, right? So let's save this. Now if you notice, so this is the pod level volumes that we have given, okay, and this is the name. Now next, this is very important. Now these three line you can see, right, what actually this is doing, this is actually a YML document separator. That means by this we are simply telling that okay, now we are actually writing a new resource in the same file. So this is a new resource, okay, so that is the reason this is the separator that we are using. Now again, this is the app version. Now kind, this one is the deployment. Now we are writing a service for this, so this kind will be service. Again, this is the metadata. This will be inside this namespace or inside that particular folder I am talking about, just for explaining purposes. Okay, the namespace is simply, it's like a folder where you are having all the resources inside that namespace. Then you are going to have the spec. This is the selector. This is by what it will actually find that for which label I need to run these resources. So in this case, this is Mongo, this is what the port will run, and this is the type is the cluster IP. Now cluster IP is actually internal only, right? What it will do, it is going to expose a stable virtual IP inside the cluster, right? So this is what we need, right? So that your DB will not be exposed. So this is actually happening internally. So this is about the first Mongo YML file deployment and services that we have created. Now what will be the next step? Next step, we are going to create the same thing for backend and frontend. So let's do one thing. Let's create one more file here. So I'm going to do it 02. Let's give a hyphen, and I'm going to give this as backend.yml. Now again, I'm not going to write it. This is going to take a lot of time. It is the exactly same thing, but I'm going to explain that what is happening, and also I don't have to explain. You'll be able to understand if you can do for one. So let's go here, and I have already created here. So let's copy all this from here. And then I'll paste it here. Okay. Now again, I think let's not recap everything. I think it is become repetitive. The first of all, you can see that we are having the kind, which is deployment. Then you have the metadata, namespace, and this is the level. Now you can see in the spec we have 2 replicas. So basically we are simply desiring pod replicas here, right? This is just to explain you that how actually this is working, right? So first we have taken 2 replicas. Next we are having the selectors. This is the match labels, right? Next we are having the containers. Containers is actually important. This is simply the name of the container. Image, this is the same thing. What is image pull policy? You can see if not present. So what actually this is doing here? So this is actually telling that kubelet will pull the image only if it is not present on the node. I hope you're getting. That is the reason we have taken this image pull policy. This is the port, this is the env, right? This is the name of the env, this is the value. Okay. And then we have some other properties like readiness. So this is simply will tell to determine whether the container is ready to receive the traffic, right? And here it is very important. This will actually help us to understand that only ready-made or only ready pods are added to the service endpoints, right? Then we have some HTTP. So this is a health path we have added here. So what it will do, this is going to perform say HTTP GET to this particular endpoint /health. Then we have some initial delay seconds. So what this is doing, simply telling that okay, you just wait for 3 seconds after container will start before probing. Okay. Then some other liveness. So what is liveness? So this will simply tell kubelet whether the container is alive or not. So now you can explain. You can explore all these properties. You can search each and everything, and you can see, right, in Google also you'll be getting all this in depth. Now for the service part, again the same thing, right? So it's like kind is service. We are creating a service. This is the metadata, right? This is where see protocol is TCP here, port is 5000 it is going to run, and again the type is a cluster IP. So this is what we need for our backend YML file. Similarly, we need to create for front end, right? So again I'll create one for front end. So let's do here 03 hyphen. I'm going to do here front end and dot, let's give YML. That's it. Now let's go here, and I have created these also, right? So we'll just copy from here. We added some comment also. That's it. Copy this, and we'll just paste it here. Again the same thing, right? This is the deployment, metadata, replicas 1. We have a template. Then we have a front end. This is the name of the image. Again the image pull policy, and this is the service. Now what we need to understand that how all these files are actually working together. Now let's start with the namespace. So what namespace is doing? So namespace is actually groups the objects. The Mongo deployment actually launch a Mongo pod and a Mongo service, and this is going to give a stable DNS name. Now remember, we have two things here, right? So first it's creating a deployment, or it's going to launch a pod, because at the end deployment is going to create a pod. And then we also have a Mongo service which is going to get or give a stable DNS name. Backend deployment do what? It's going to launch 2 backend pods. We have 2 replicas here, right? Each pods, very important, each pods is going to read the Mongo URI env. This is the env that we have given, and this is going to connect to this particular MongoDB database, right? Then backend service gives a backend stable internal endpoint, right, for other pods, so that they can call it by this 5000 from this 5000 port. At the end, you can see when we are going to call the front end, then we will be able to see the result, right? So, and what you need to understand is actually how we are creating the deployment and how the services are actually working, and this is what the YML structure is happening. If you remember in the previously, whenever we have done this one in the imperative way, we have written all of this line by line. I hope this is clear. So now we need to run this. So here we need to follow quite a few steps, right? So let's do one by one. First, let's go here and let's see if we don't have anything else here. I don't think we have. Alright, so now what I'll do, right? First, let's go to my containers. Let's go here. Now remember, this is happening because we have done the container to container communication. Remember, this is actually running on this localhost, which is fine. I'll go here. Let's expand this. Alright, so now let's start with building the images first, right? So we'll do docker, and then we're going to do build -t, and I'm going to give this one as backend :local, and let's go to our server directory, right? And hit enter. Okay, so I think this is done. Now let's clear this. So I'm going to do docker, then I'm going to do build, and here we are going to build arg, and here what I'm going to do, right, I'll give this one as vit underscore, so I'll do API underscore URL, and this will be equal to http :localhost 5000 / API -t, and here what I'm going to do, I'll do frontend :local, and here we need to go to our client directory, right? So let's see one. So we'll docker build arg, then we have vit API URL http localhost 5000 / API tag frontend local, and then go to the client folder, the context, and build it. Enter. Awesome. So once we will do that, now let's clear this. Then I'm going to do Minikube. Then we are going to put the images into our Minikube. This concept also I've discussed in the first part. So what you need to do, image load, and the name of the image, which is backend :local. Hit enter. This will take some time. I'm not going to pause this, so let's see how much time it is taking. Enter. See, it's taking too much time. Let's wait. Awesome. The same we need to do for front end :local. Awesome. So now let's check. So we'll do Minikube, then image ls. Awesome. So we have the images. Now let's clear this. Next thing what we are going to do, right, now we'll do step by step. First we are going to create the namespace, then we are going to run or apply the Mongo YML file, then backend, then frontend. So how we are going to create the namespace. So we're going to use kubectl apply, then -f, and the name of the YML file. So we'll go to k8s folder /00-namespace.yml. Awesome. Hit enter, and this is created. Now once the namespace is created, now that means that folder is created. Now consider again, don't think like I'm telling the term folder multiple times, just to explain in a simple way. So front end folder is created, now all the resources will be inside that folder. So similarly namespace is created, now everything will be in that particular namespace object. Now what I'm going to do, right, so I'm going to apply the MongoDB deployment service both. So we're going to do kubectl, we'll do apply, and then we are going to -f k8s, then we are going to go to 01 -mongo, then .yml, correct? This is the name of the file, enter, and this is created. Now let's see how we are going to check it. So I'm going to do kubectl -n, and here we're going to give the name of the namespace, which is DevOps part 3, right? We'll do wait, and here we are going to give a for condition. So do for equal to condition, and here I'm going to do ready, and let's give a pod -l, and then app name is Mongo. Remember, this is the name we have given, and I'm also going to give a timeout. Let's give maybe 180 seconds. Okay, condition met. And now what are you going to do, right? So we'll check one more time. So we'll do kubectl -n DevOps part 3. I'll do check all the pods if it is there or not. So we'll do get pods -l app equal to Mongo, right? And then I will do -o void, enter, and this is running. Awesome. So now Mongo deployment and service is now ready. So now we need to apply the backend one. So I'm going to kubectl. Okay, let's remove clear this, it will be easy. So do kubectl. Now you can do with like without even seeing this also, right? It is same. So we'll do -f. So we'll go to the folder, then backend. So 02 -backend .yml, enter. Awesome. So this is created. Now similarly you can also do the same thing just like we have done, right? So okay, let's do it. So what I'm going to do, right, so let's go to this one. So this will be same. So kubectl DevOps part 3 wait condition, this will be ready, pod app is, now this will be app will be backend, timeout will keep same, enter. Awesome. Then we will test that also. So here we need to do backend. Awesome. So this is running, and you can also check the SVC. So if I want to check, so look kubectl -n DevOps part 3, this is the namespace. So to get SVC, and here you need to give backend, then -o void. Okay, so this is done. Now do the same thing for front end. So do kubectl apply -f, then k8s / we do 03 front end .yml, enter, created, and do the same thing, right? So here this will be front end, enter. Then we also do for this one. Also you can check the SVC also, so let's check that also. Awesome. Now if you want to check all the pods and services in that particular namespace, so we can re-verify once again. So do kubectl, then you are going to do -n, we'll give the namespace name, which is part 3, and here we are going to do get pods, okay, comma you need to give, and then you'll give SVC, and then -o, and then I'll do void, enter, and you can see everything is now running. Okay, your service backend, front end, and Mongo also. Awesome. Now this is done. Two things we need to do now. Port forwarding we need to do, so we need to forward the port for both front end and backend. So let's clear this, and now first let's start with the backend. So I'll do kubectl -n DevOps part 3, and here we are going to do port forward, and I'm going to do SVC, because remember we have created the SVCs for backend, and I'll give 5000, which I'll forward to 5000. Till the time this is happening, let's open one more, and we'll do the same for front end also. Do kubectl little, first I'll do -n DevOps part 3, and here I'm going to do port forward, and here what we'll do SVC / front end, and I'm going to give this one as 5173 to 5173, enter. Alright, so the handling connection is done, so you can see that this is done, and this is also done. So now what I will do, right, so if I go now, you can see that in the localhost, that Nginx one that we have done, that Docker using Docker Compose, right, so that is already running. So what we can do, right, first we can go here and let's pause this or stop this for now. Let's wait. Okay, so this is done. So I actually wanted to check that if it is working or not, right? So now I'm going to refresh this. So it's not, which is correct. So now I'll go here to 5173, refresh this, and this is working. So this is the Kubernetes deployment just now we have done. So that is the reason I stopped that. I hope you're getting right. So here if you go, right, so you can see that it's actually calling this one. So now your app is running through your Kubernetes cluster. You can see if I add this and everything, this will work as usual. The main idea, if you refresh this, you can see the data is there. The main idea is not this. The main idea is that to understand that how the process is working. I always mention the thing, right, that how this YML file you have written, what is this deployment is doing, what is the service is doing, how both things are connecting. This is definitely not completed yet. A lot of things are there, like even if I create a complete video on this only, but I just don't want to do that. There are a lot of tools that are left in this DevOps ecosystem that we are going to cover incrementally, but this is the beginner or intermediate place that you can start. This is the best way to learn. Okay, so we have learned the concept of namespace, creating Mongo deployment service, backend deployment, backend service, front-end deployment, front-end service, or SVC, right? So you have created all of these. So now what we need to do in the next section, we are going to learn about configuration. Now now you might ask me, what is configuration? If you see, if you go to this, let's go to the backend, right? You see we have given this URL here. Now normally you should not hardcode your env and everything, right? So that is the reason we need to manage the env variables or secrets in such a way so that will be handled in a separate way, and then every time any env changes we don't have to redeploy those or rebuild those images again. So let's see how we are going to do that in the next part. Alright, so now moving to the next section. So in this section what we are going to understand, right, that how we are going to manage configuration and secrets in Kubernetes. Now first of all, as usual, so we'll start with the that why actually need it and how we are going to do it, right? So then we are going to practically implement in our Mon application. Okay, so let's do one thing. Let's copy this, right, and then I'll just bring this here. Okay, so let's start with that why actually we need configuration, right? Now the first thing, so we have two kind of things that we need to understand. So one, we have something like which is non-sensitive infos, and then you have the sensitive information, right? Now when I'm talking about non-sensitive information, like let's say you have API URLs, then you have something like feature flags, right? Feature flags are one of the most used in like large production grade application. Let me keep this one little smaller. Okay, now what is, if you ask me what is feature flag, so it's like, let's say I'll explain this on a very simple way. You are managing a e-commerce application, all right, and then let's say in a year 2-3 times, for example, let's say in Christmas time, you will give some offers to all the users that uses your e-commerce application. Now in that case, what feature flags will do, right? So for example, let's say you have a banner that you need to render in your UI, whenever this feature flag will be true, something like that. So you have some kind of configuration so that you don't have to go to and make code changes and then redeploy. Automatically, if that feature flags is coming, the banner will automatically render in the UI, right? So this is kind of a feature flag. Then you have like logging in one of the, I think I already mentioned logging multiple times. You can have different types of logins, right? When we are going to cover monitoring and logging in the next part, and also in this part I'll give you, if I get some time, so I'll give you some of the basic idea. So logging in is very, very important. Let's say you can have different types of logins, for example debug log, right? Then you have error log, info log means which logs you are showing in your UI. Debug means you want to debug something. Error means, let's say your user faces some kind of error, so you want to get those logs and you want to store in some place. And then you can also have your DB host names. So these all can be non-sensitive type of configuration, right? Sensitive, very, very important, mostly used passwords, right? Then you have the API keys, very important. API keys also can be different. So in your dev you have API key, and then you have a stage environment, there the API key will be different. Then you have a prod, something like that. DB URLs, very, very important, right? And then also you can have some kind of certificates, right? So this also comes under sensitive information. What will happen if you just hard code these inside our images, right? For example, if you go to our backend here, and you see we have actually given the URL here, the value, right? And this is not good. For example, you need to rebuild the images every time if this config changes. So that is the one of the so you need to rebuild, right, images if your config changes. So that is first thing. Then definitely there is a risk exposing the secrets in your Git repo or in your Docker file, right? And very, very important, you cannot separate environments, right? And this is very important. Let's say, as we already mentioned multiple times, that you will definitely have a dev environment, a stage environment, you have a prod environment. Now some applications which are very strict or very high level in the means high priority application like P0 or P1 application, they will also have a pre-prod environment. Pre-prod means before you deploy in the prod, there will be a pre-prod check, right? So you cannot do separate environments very easily. Now here Kubernetes gives two built-in objects. One is called ConfigMap, so you can just go and just read all of these here, right? And then you have the secrets. So both the things I'm going to cover. Now let's go here, right? Okay, not here. So I'll go to this one. So let's start with the ConfigMap, right? So what does ConfigMap will do? So ConfigMap is simply going to store non-sensitive config. How it's going to store? This is going to store in key value pairs. Okay, so you will have a key, then you have a value, and in these pairs it is going to store. Now I'm going to give you one example. Let's say we have a Mongo host, right? So for example, I want to store Mongo_host, and then I'll give you the name as Mongo. So this will be my key, this will be my value, right? Let's say you want to get the different kind of logs in your application. So you'll give something like log level, right? So what will happen, so this can be your debug log, this can be your error log, this can be your info log, it can be anything. So these will be, or these can be consumed by by pods as environment variables. So these can be consumed by pods as env variables, right? Variables. Okay, and also this can be mounted as files inside a volume. What is the advantage? Now you can update configs very easily. There are some limitations that this is not encrypted, and this is visible to anyone with access. So you have to be very careful that what you are putting inside ConfigMap, right? As I already mentioned, if it is non-sensitive, it's absolutely fine to put all this in your ConfigMap. Now what is secret, right? So secret is simply as the name suggests. So here you are storing your sensitive informations, right? So sensitive infos, right? So it can be password, it can be tokens, it can be DB URL, are already mentioned, it can be API keys, and these usually stored as a base64 encoded in your YML, right? So it's actually not real encryption, but it's better than the plain text if you directly give, right? Now these also can be consumed the same way as config maps. So these also can be consumed by as env variables, right? So these can be also consumed as env vars, or it can be using files, right? Now I'll give one very important best practice here. So here what you should do, right? You should never check secret YMLs into public repos. This is very, very important. Now what we are going to do, right? Okay, let's do one thing. I will give you one idea that how it will work, so that it will be little easy to understand. Let's take one here. Okay, so let's say I'll give this one as this is your config map, or this is your secret. What will happen, let's see, this your pod spec will be here, or this is basically your deployment, and here this will receive how? So it's going to receive via env. So for example, let's say I'll give mongo host, or I'll give something like mongo URI, something like that, right? Also this can be accessed via volume, right? I already mentioned this can be you can also mount inside your files, right? So it can be mounted as files inside a volume, so it can be via volume also. Now one more point I wanted to explain here, and that is configs actually lives outside code, right? And pods are going to consume those configs dynamically. So how we are going to do that? Now this is not that much difficult to implement, right? But the concept you need to understand. So first you can just go through this. Also I'll highly suggest you can go to the official doc. It's also very, very well written, right? All the details are mentioned here. The first thing what we're going to do, we're going to create some files, right? So first we'll go here, and inside our Kate is folder, I'm going to create one more. So let's give this a name as config map. Let's give config map.yml. So one will be config map. Then let's create one more, which I'll give, for example, let's say for this one we are only using mongo URI, so I'm going to give secret mongo.yml. Okay, so these two things we need. Now let's start with config map.yml. So what we're going to do first, I'm going to give an API version. So let's give this one as version 1. I already mentioned, explained all of this in the previous part. Now kind here, if you go, right, let's go here and search for kind. So kind will be config map, right? So I'm going to copy this, and this will be config map. Now I'm going to give a metadata. Now inside metadata, what I'm going to give, right? So I'll give this one as name. So this will be the name. I'm going to give this one as app config. Whatever you want to give, you can give. And then we need to give the namespace. So what will be the namespace, right? So here I'm going to give a namespace. So this will be the namespace that we have created, which is DevOps part 3, right? Now this is the thing that we need. Now what else we can add here? So let's add one data here, because we need to add the data, right? That how it's going to read it. I already mentioned it's going to store as part of what? As part of key value pairs. So I'm going to give a first one. So let's give this one as mongo underscore host. Okay, and this will be mongo. What is this? This is the host name of your mongo service. Next we are going to give one more, which is our front-end URL. Now both are non-sensitive, so I'll give front-end URL. This will be HTTP, so we'll do localhost, and this will be 5173. That's it. So this is a very simple config map we need. That's it. Now next thing what we're going to do, we need to create a secret mongo file. So here also we will give API version v1. Then we are going to give a kind. Now for this one, kind will be now secret. Okay, and you can also double check, go to secrets. So kind will be secret, right? And here I'm going to give a metadata. So metadata I'm going to give the name. So let's give the name as mongo secret. Then after this I'm going to take a namespace. So namespace will be DevOps part 3, and then I need to give a type here. I'm going to explain what we are doing here. Opaque, I don't know how to pronounce this one, but here we will be having the data, and this data will be Mongo URI. Now this will be now a base 64 encryption that we need to use, but how we are going to do that, so that I am going to explain. The first thing, this type is nothing but this is going to so this is just, we are telling that we are creating a generic key value secret. That's it, right? So this part I already explained that. Let's go through one more time. So first one, you need to consider this data, right? Data is nothing but key value pairs, right? So all are plain text. So this is the key name, this is the value, this is the key name, this is the value. Same this one. But now how I am going to get the data? Now to get the data, to get the Mongo URI. So how I am going to do that? So for this one I already have WSL installed. So you also should be having the WSL installed, right? Just open this one. And what you will do, right, simply here you run echo -n, and here inside this, now let's go to our backend YML and copy this, okay, or you can copy whole this part, copy this one, paste it, and here what I'm going to do, right, I'm going to give this one as base 64. That's it, right? Now hit enter. So it's going to give you a encoded string. So you have to copy this, and then we'll go here and just paste it here. Okay, so this is what we need. Now is this done? Not yet. Why? Because if you go to your backend YML, right, you see we are still using this as hard-coded. So you have the name, this is the value, and other things. What we need to do, we need to actually change or modify this backend YML file. Now here one very important point I wanted to explain. You have two options. The first one, you can modify the exact same file, and then what you need to do, you need to rerun the container again, right? Or you need to run the services again. But what I will do, right, I know for some beginners it will be little tricky to understand, so this is what I have done. If you go to my Docker desktop, you see that I don't have any containers. I deleted everything. If you go to images, you see I don't have any local images for my Marn application. Why? Because I will do the same thing again from scratch. So let's see how we are going to do this. And before that, I'm also do this. I'm not going to configure the same YML file. Instead, I'm going to create one more for backend. Okay, now again it's up to you. You can modify the exact same YML file and do the same process again, or if you want to keep this one clean for your learning purpose, you can create one more here and give this one a different name. For example, I'll just do what I'll go here and then I'm going to create a new file and I'll give 02 only, but see, I'm going to give this one as backend configured. I hope you're getting. Means instead of this backend.yml file, I'm going to use this YML file. And in this file, what I'm going to do, right, I'm going to now use that secrets and the config instead of hard coding. I hope you're getting. So you have, again, I'll repeat, you have two options. Either you can modify the exact same YML file or create a new one. I will suggest create a new one. Why? Because it will be easy to understand, so that you can easily check and compare that how it is working without config and how it is working with config. So let's do that in the next part. So we have a lot of commands we need to write. So I'm going to just collect all of these, keep in notepad, so that we can run every one after another, and then we are going to see how it will work. So let's do that in the next part. Alright, so let's get started. Okay, so first we'll run everything from scratch again. And you can see that I already mentioned that all the images, all the namespaces that we have created, so we'll do from first. So first thing what we're going to do is I've just collected all of these. You can get all of this in the repo. So I added in my website, so you'll be able to download from there. So first let's start with creating the image first. Okay, so I'm going to copy this and let's go here and let's close this also, and then I'm going to paste, enter. Okay, now let's build the front end one. So I'll copy this, clear, and paste it. Okay, I think we have done some mistake here. Let's see. I think we need to give the tag here. So once this is done, right, so now we need to load all these images in our Minikube. So I'll copy this. So let's start with the backend one first. Okay, so this is done. Now let's do the front end. Now once this is done, right, so first we'll check the test the images. If those images are available in Minikube, then we are going to even apply. See, if you notice, right, I'm applying and creating all the namespaces again. I already mentioned it because I've already cleared all of this so that it will be easy to understand. The same thing I'm going to do again for the next section, which is another very important section. So let's first complete this one. And also, whenever you will be doing a project, let's say freelancing project or whatever, you should always use the config map and secret. Don't use the previous one. So previous one, I think, just for the basic purposes, right, that when we are adding all this directly in our backend YML file, that you should not do it. So now let's copy this and let's check. So both are there. So now what I'm going to do, create the namespaces first. So copy this. Awesome, clear, and then we need to apply the config. So this is the file that we have created, right, config YML file, right? So we'll paste it, so it will go to this folder and then check the config file, enter, and this is created. The same thing we need to do for the secret Mongo. If you have given different file name, just modify based on that. Created. Now what are you going to do, you can check it, right? So if you just copy this directly and check if it is present or not, and you can see that you'll be able to see this front end URL Mongo host. The kind is config map. Also you can check the secret also. Copy this, paste it. You can see Mongo URI is present there. Awesome. So now our secrets are added. So now we'll be adding or applying our Mongo YML file. So copy this and paste it. So deployment service both created. And we can also test it, right? These I already mentioned in the previous section also to test. So first we'll check the condition if it is ready or not. Let's see. Okay, I don't know why it's taking that much time. Let's do it. Awesome. Now I'll just copy this. We'll check the pods. It should be running. So it's running. Mongo pod is now running. Now here it is the important part. Now see what I'm doing here. Here I have this backend config YML file, but okay, I haven't added this, so I'll add this. So what I'm going to do, right, instead of using this YML file, I'm going to run this one. But before that, we need to just copy this one. So I'll just created this one here, right? So let me just check. So let me copy this one from here and I'll paste it. Why I'm not writing? Because I've already written all this in the previous section. What is the change? If you just go to the backend YML file and change, if you see this part, env, we are using this, right? And if you go here, just check what we are doing. We are simply doing the env from a config map reference. The name of the config map is app config. So if you go here, this is the name that we have given, and the secret reference is from your Mongo secret. And this is what we have given the name here. I hope this is easy to understand. And the key value pair we already have here, so we don't have to add it. So now this is actually in my backend config.yml file. So I created this one intentionally to keep this one separate. So what we need to do, right, instead of running this backend.yml file, we need to run the configured file. So I'm going to clear this one, and then what I will do, simply we'll just go here, copy this, and then run this. Awesome. And then we'll check again if it is ready or not. Copy this, condition met, and we'll go here, copy this, it's running, and also we'll check the SBC, copy this. Okay, so now the same thing we need to do for front end. So I'll copy this one, created, check, it is the same thing. We are just simply creating a config map and a secret, and that's it. And then based on that we are creating the deployment. And once this is done, now we can check all the pods and services at once. And for every command, you see we are using the same workspace that we have created, right? All are running. Now what we need to do, we need to do the port forwarding, right? So I'm going to for backend I'll forward to 5000, enter it. Now never close this one, just open one more, and then just do the same for your front end. Okay, and now what we are going to do, simply just go here, copy this, and let's see what is happening, right? So let's go here, and it is running. Refresh this, new task, create, working fine, right? So it is the same thing, right? But what we are doing, simply we are not hard coding the configuration directly in the backend deployment. Instead we are creating a config map and a secret, and based on that we are just configuring here and creating the deployment. Now all these commands that I have added here, right, these are actually very important, right, these things. So I'll definitely add all of these. What you need to do, you don't have to memorize all of these all are actually, you see, all are connected with each other, right? So you have to understand what is happening here, why you are creating namespace first, then we are creating the deployment for Mongo, then creating deployment for backend. I hope you are getting it. So just go through all of these, practice multiple times, then you'll be able to understand very easily. So with this, our configuration and secret map section is completed. Now let's move on to the next section. Alright, so now let's start with the next section. Okay, now this one is going to be very important. So in this one we are going to cover what is actually Kubernetes Ingress, right? Now before, I know if you're a complete beginner or if you're learning Kubernetes for the first time, this term might be very new, right? And you will understand that why in the first section or in the prerequisite in this particular video I have covered the Nginx and the container to container communication part, right? Especially the Nginx, right? What is the work of Nginx and everything. So if you haven't watched that particular section in this video only, please watch it first and then you can come back here. Now before I start this one, right, this what is Ingress and how we are going to use Ingress in our Kubernetes, all these things, we need to recap all kind of service types, especially cluster IP that we have covered, node port and the port forward. All three things we have covered in this part 1 and this part 3 also in the previous section. Why? Because it is very important. Although I will be repeating some of the concepts, you will see that okay, that he is repeating some of the things, but there is a reason. So first, don't skip for next 20 to 30 minutes. It's very important if you want to understand what is Ingress and how we are going to apply practically in our MAN application. Now okay, let's first give some text here. Okay, so I'm going to give Kubernetes Ingress. Okay, the first thing we need to recap all kind of service types that we have understood, right? First of all, we have the cluster IP, then we have the node port. Remember, we have covered the concept of node port, and port forward we have used multiple times. Now first let's see that how we have been exposing our application so far. Now remember, one very important point I am repeating multiple times again and again, that is in Kubernetes, whenever you will create a pods are actually short-lived, right? Short-lived, and their IPs keep changing. if you remember that I already mentioned that even if you kill a pod, what will happen in the deployment, we have the concepts of replica sets, right? So replica sets is going to create another pod, something like that. And because pods are usually short-lived and their IPs keep changing, so that is the reason we have the concept of services. Why? Because services act like a stable entry point, right, for a group of pods. So let's say you create a pod, and then here let's say you have IP1, and then suddenly the IP changes, right, IP2. So it will not work. So that is the reason we have the concept of services, right? So services will always have a stable entry point. But services also comes in a different flavors, right? And for each and every services we have a pros and cons, right? So let's go each and every services, what are the advantages and why actually we need the concept or the topic Ingress comes into picture. First we'll start with cluster IP, right? Now remember, cluster IP, I'm going to remove this one, these ports, this is not needed. Now cluster IP actually the default one, right? That means by default, whenever we are going to create any service, so create any service, what will happen? Kubernetes is going to give a default cluster IP. Very, very important, right? That means this IP is only accessible where inside that cluster network. So this IP is only accessible, I'll do only accessible inside the cluster network, right? So now remember we have run this command. I'm not sure if you are able to recollect the kubectl, and then what we have done, remember we have done the get and then svc, right? And if you see, if you just run this one, let's say you have some application ready, you'll see that it will give you a name, right? It will give you a name, it will going to give you a type, and then there will be a cluster IP, something like that, and then there will be a port, right? So this name is nothing but the name of that service, type is nothing but the cluster IP will be the type because that is the default, and then there will be a type IP, something like let's say 10.96 blah blah something, right? And then you have a port, let's say 5000 you're running, and then there will be a TCP. That means what you're telling simply that this backend service has a cluster IP of this, right? And this is running on this particular port. But when you try to access using this URL, so let's see if I do HTTP colon and then I'll give this IP, let's say 10.96.xyz whatever is there, and then if you just go to 5000 port, and you will see that it won't work, right? The reason is because this actually perfect for your pod to pod internal communication. Means let's say you want to have a backend pod, you have a MongoDB pod, in that case you can use this. But if you want to expose this one to an outside world, then it will not work, right? So this is the default cluster IP, where the most important part is here that Kubernetes is going to create a cluster IP by default for that particular service. Then we have the concept of node port. Again, I'm just writing all this like this, okay, I know, but when I'll add the notes, right, that will be much more structured way. So you can just you just download from my website, and you can make revision for your interview purposes also, because these all are very, very important interview questions also. Now node port is where what will happen, right? So how it will work? So node port exposes the services on a port. So typically range will be between 30,000 to 32,767, something like that, right? So for example, let's say if you do kubectl get svc, now if you created a type of node IP, so what will happen, there will be the name of the service, let's say backend, and then the type will be something like node port, and then there will be a cluster IP, something like let's say 10.96 point something xyz. And here what will happen, right, you'll be having a port, right, 5000 colon, let's say it's running on this 30,000 port / TCP. Okay, now what will happen from browser, when you're going to hit like this, so I'll do HTTP, and then here I'm going to give what, I'm going to give the node IP, that IP I am having, and then if I try to access 31,000, let's say /API something like /task from your browser, now you can actually hit this one. The problem is it's very, very important that each service will have a separate port. Now if I want to explain this one very simple way, let's say you have a front-end application, right, and something like this. So okay, let's consider more simpler way. Let's say you have a front end, you have a back end, something like that. and you have a auth service, something like that, anything you can consider. Now each and every service will have a port which will run, for example, HTTP, and here I'll give something like IP, and let's say this is running on 31,000. The next service is running on HTTP and I have the IP, and this is running on maybe 32,000. I hope you're getting right. So each and every service will run on a particular IP. Now is this realistic for your real world application whenever you will be creating a production ready application? Absolutely not, right? So this is very, very important. Now next thing what we have understood, okay, this is 32,000, that is the port forwarding, right? So what is the port forwarding? Port forwarding is nothing but it's a temporary tunnel from your laptop inside the cluster, right? Remember we have done kubectl port forward, then the name of the SVG, let's say svg/backend, and then we are forwarding the port from 5000 to the localhost 5000. Remember we have done this one, right? This is great for your debugging, your local development, but you can't expect when you have a real world application that your customer is going to set up the secret where, right, and then they will access like that. It's not going to work like that, correct? So it's not shareable, scalable, and also it's not at all suitable for your production. Absolutely not. So you can't use port forwarding in a production level application. So that is the reason you have to understand now why Ingress will comes into picture, because there is a problem statement that why node port. So when we are talking about the node port type, this doesn't scale, right? So now if I want to give this on a very clear example of problem statement, so let's see the problem statement. Why I'm explaining all of this, then only you'll be able to understand that why actually you need it, or else directly just jumping into that, it will be difficult. So here, because your node port concept, I'll give node port concept doesn't scale in a real world application, right, or in a prod application. I already mentioned why, because each service exposed via node port gets a random high IP between that range 30,000 to typically will be between this. So there will be 30,000 between 32,767, right? Now I'll give you one example how to give this one. Okay, so I'll take this example. So let's say you are on a pizza website, right? And now normally what will happen, you'll go to pizza.com, correct, or let's say burger.com, something like that. Now let's say I go to this website and the owner of this website tell me that okay, you will get pizza from this endpoint. So we'll do pizza.com, right, and then you have to do colon 31,000. If you want to get some kind of drinks, you have to go to, let's say, pizza.com and then colon 32,767. I hope this will make the concept simpler, that each and every service is running on a different port. So what will happen if you want to go do this kind of things, you will never go back to that website, right? It's not going to work. So node port is not scalable, right? So when you have a real world application, what will happen, you will be having too many services and too many ports. So just remember this key. So too many services means what? Too many ports. Now let's say you have a, so I think if you have covered my Node.js microservices, I actually covered all of this. So let's say you have an auth service, let's say you have a payment service, let's say you have a cart service, or let's say you have a file upload service. It can be endless, right? There can be n number of services, and every service will run on a particular port. That means it's like you have a home but you have 20 entrance, right? So each and every entrance is a different service. So it's very difficult. And another very important downside I totally forgot to mention, that is node port doesn't support domains. You can search this one, right? You can just search for node does node port supports domains. You will see that it actually don't. So that means it's what is actually node port. So it's actually IP and port based, right? So that means let's say your cluster, you have a cluster which is running on this particular port. I'll just give some dummy example. Let's say 192.168. let's say 99.101 something. Then that means how you are going to access this. So you have to take this IP, correct? So this is your IP, and then you have to give what? Colon a port. So it's a IP plus port. That means in real world, I already mentioned this one. So let's say you have a multiple auth services. So for each and every services, you have to go to that particular port and you have to access. So because of all of this, and okay, one more important point, sorry, I want to mention this also because this is also important. There is no SSL termination, because now if you see any real world application, every website uses HTTPS, right? But here Notepad doesn't give you a straightforward way to add SSL certificates or to terminate HTTPS, these kind of things. So what you have to do, right, you have to do a manual, or you have to implement this on manually with a load balancer, or very important, external reverse proxy, right? So that means with all of these, what you understand that Notepad is absolutely will not scale in a production ready application. So that is the reason we need something called Ingress, right? Now I hope this will make this concept clear, right? See, I know I've taken almost 10-15 minutes to explain all of this, but you will understand why these things are important, right? Because when you learn Kubernetes, again I'll repeat the same thing again and again in all the parts. This is not a simple topic to understand, and I am pretty sure most of you will agree with me. Kubernetes is not at all simple. There are a lot of things, there are endless topics, and to remember all of this, how you're going to understand and apply in a project, it's very difficult. You can't memorize each and everything. First of all, whenever you're learning any topic, right, you need to understand that why actually we need it. Again, I'll repeat these things multiple times. When you are learning Ingress, you have to understand that why actually we need this kind of thing, right? So that is the reason I explain all of these, that when you are talking about the services, we have the cluster IP, port for node port, all of these are not scalable in a production ready application. So that is the reason we will move to something called Ingress. So let's start this one. So again, what I will do, right, so we'll explain each and everything, that what is Ingress, how it will work, and then we are going to apply this one in our Mon application. Alright, so let's start, right? So first we'll start with what is Ingress and how it will work, right? Also, I'll suggest that you can go to the official documentation, and here it is quite detailed. All the things are mentioned, and you can see the prerequisite and how will be the structure and everything, although I'll be explaining each and everything, right? So first let's see, so I'll give Ingress. So first, what is Ingress, right? So let's learn this one in a very simple way. So you think this one as a smart router, right? So it's kind of a smart router at the edge of your Kubernetes cluster. Now if you go here, right, so let's see what it is telling, that make your HTTP network service available using a protocol ever configuration mechanism that understand web concepts like all blah blah. The Ingress concept lets you map traffic to different backend based on rules you define via Kubernetes API. Okay, now the thing that what I wanted to understand, and that is, if you see that you have your client, then you have your load balancer, Ingress load balancer, and this is your cluster, and the same thing I mentioned here. So it's a smart router at the edge of your Kubernetes cluster, right? So how it will work? The first of all, so it listens, so I'll give it listens on standard web ports, right? So for example, let's say I'll give you like 80 for HTTP, and then you have 443 for normally HTTPS. And how it will work? So it is going to take all your incoming requests. So take all incoming requests, and then based on the rules you defined, so you are the one who will define all the rules, it's going to send this request, so sends them to the correct service. Now if you can I'm pretty sure this will be little familiar. This is exactly what Nginx usually do, right? And this is the same thing we have discussed in the first section of this particular video. That means how it is helpful, that instead of exposing your every service separately like this, like here like this, what we are doing, simply you are just creating one entry point or one door in your home, something like that. Right, now let's see how it is going to work in our Mon application, in the Mon context. So what will happen, right? So it's, let's say, without Ingress, what will happen? So you're going to have your, let's say, backend. I'm going to call HTTP, and then I'll give something like 192.168.99.101, something like that, and then I'll give here, right, so 31,000, and then it will go to /API and /task. This is what we have done, right? And similarly your front end will be running on the same thing, but I'm going to copy this just to give you an example, and then maybe this is running on 3200. This is without Ingress. With Ingress there will be a huge change, right? So what will happen? So whenever I'm going to integrate this with Ingress, based on the rule that I'll provide, there will be one clean domain. So consider, because we are doing this one locally, so let's say I'm going to give a domain like HTTP, and then I'm going to give this one as a mon application, right? So I'll do like, let's say, my app. This name you can give any name you want, .local. So this will be my clean one domain. This is the entry point. This is where Ingress Nginx load balancer will comes into picture, right? So what I'll do, this load balancer is going to pass through this Nginx. This is going to check that what routing rules you have defined, and based on that it's going to call that particular service is going to call the pods, right? Something like that. So you have a one clean domain, and then these Ingress rules will decide that this is my front-end service, and then whenever, let's say, I'll go to /API, I need to call the backend service. Now see, this is exactly same to the concept of Nginx, right? So that means you don't have to care about the IPs, you have to port, you simply use HTTP myapp.local. Whenever you will enter this, your front end will load, and your backend will be like HTTP myapp.local /API/tasks, something like that. Okay, now let's consider, or let's not consider, let's understand this one with a real world application. So consider what we'll do, something like Amazon.com, right? I'll consider this one, and here what I'll do, let's say, whenever you don't have something like this Ingress, what I'll do, so I'll do Amazon.com, then I'll go to 31,000, then I'll go to, let's say, cart page. Then again, once the cart is done, I'll do Amazon.com maybe 32,000, then I'll go to the payments page. This is the exact same concept we have discussed, right? Now here what we need to do, we just have to type Amazon.com. This is going to our home page. This is I'm talking about with Ingress, and then automatically we'll just simply go to Amazon.com/cart. It's going to call our cart service, and this is exactly what is also happening, right? So they have, maybe, I'm not sure how they have implemented, though they'll be having different microservices, right? So different services will be there. That is 100% that will be there, because it's a huge application, very production level application, millions of users uses every day, right? So you need to have some kind of multiple services, separate services, and I'm pretty much sure for every service they will be having separate team that handles, right? So for payments they are going to call the payment service, something like that. Now let's understand one important interview question, that is that what is the key benefits that I'm getting if I use this. So first of all, there will be one clean entry point. Why this is important? Because you don't have to use multiple ports. Then path based routing, right? For example, let's say if I go to /API, this will happen. If I go to /auth route, this will happen, something like that. SSL termination, this will be there. Okay, means you can easily do I'll do easy HTTPS setup. Then you have load balancing, right? And also definitely 100% true, this is scalable, because even if you add more services, you are not exposing new ports, right? All are going through a entry point. So how the flow of traffic will work? So traffic will work like this. So you have your traffic. See, this is exactly same thing they've explained here. So I just read, see, when I'm teaching all of this, right, remember I actually read all the things from here only, right? I read all of this from here. I'll go to ChatGPT, then whatever doubt I will have, I'll paste there, I'll get a real world example and I'll apply in the project. This is the exact same thing, not only for Kubernetes, I do for each and every new topic whenever I learn. So this is another golden rule I'm telling. And if you notice, every video I have created in this channel, I never told you to use ChatGPT directly. Those who follow my videos, or even if you're watching this video for the first time, please don't use, because documentation, the official documentation is the golden resource that you can get for any topic. I know for some documentation it is difficult to understand, still you should learn from there, then come back to your local machine, make notes, apply in a project. You're not able to understand something, then go back to ChatGPT for that particular topic that you are not able to understand, not everything. Let's say you have some doubt only on this Ingress some port part, that how the port or routing is working. So paste that topic in ChatGPT or other AI tools that you are doing, because using or take leverage of AI tools are also important, because this is the future. No one can deny that. But because of that, you should never skip the official documentation and then paste there, get the answer, and again reapply those concepts in your application that you are doing. Do this for 1 month or 2 months and see when you learn a new technology how much easier it will be to learn, instead of going through a tutorial hell that you watch a YouTube video not able to understand, watch another YouTube video not able to understand, do another one. Most of the YouTubers will not tell you this because they want their videos to be watched. I will tell you, don't do it. Stick to any video that you like and then learn in this way. It will be easier to understand. So this, I think the flow I was discussing, right? So this is what I was telling, that I usually learn from here only, most of the things. So traffic, now definitely I have some practical experience also in my work that I have done in previous projects in my companies, but definitely when learning I use this method. So your traffic will come to your browser. Your browser is going to pass through your Ingress. Ingress is going to implement the routings, the rules that you will provide. It will hit your services, and services are going to get to pods, right? So if I explain this on much simpler way, let's say I'm a user and I open my browser and I just type that, okay, HTTP, go to my app.local/API/task. This is the one that we are using, right? So what will happen? You type your URL, right? This will get a web page or JSON response, but behind the scenes lot of steps are happening, and how this will work, that whenever you are typing this one, what is actually happening. So let's see this process, because this is important to understand. So here first step will be, this is your browser, and in the browser you are typing this one first, right? So copy this. So in the browser you are just typing this. What will happen? Once we'll type this one, this is going to call the Ingress controller, which in this case we're going to use, and let's say Nginx. There you are going to have rules, right? I'm not able to give the down arrow, but just give a down arrow here. So you'll be having rules here. So how these rules will be done? So first you are going to have a slash. Let's say for slash I'm going to call my front-end service 5173, and then whenever I'll go to /API, it is going to call my backend service, which will call at 5000. And then what will happen? This will do route to my Kubernetes services, to my main services that I have created, right? So simply this works like a proxy. So here you are going to have your front-end service, and then you are going to have your backend service, and these services, it's nothing but it's going to call or go to your pods or your containers, right? And here you're going to have something like, let's say you have a React app or Node or Mongo, blah blah, whatever you will be having. So this is the exact flow how it will work, and you can see the same thing it's mentioned here. Okay, we don't have to go here now. So first I will I think in interview, right, there is a possibility, if you're giving like advanced level Kubernetes interview, there can be possibility that they can ask you that give me the step-by-step walkthrough of the Ingress workflow. It's actually important that how this will work. So now let's go through one by one. what I'm explaining, just keep a note all of these. This can come directly to your interview also. Very, very important. I'll repeat once again. Browser send request. Okay, let's write it. I think it will be easy. Whenever you will write something, right, you see it will be easier for you to remember. So first step, so I'm going to give step 1. Browser sends request. So whenever browser means the user will type something, right, let's say http myapp.local/api/task. What will do? So browser is going to make, say, http get request with your host header, right? This is the first step when you are going to send the request. When we'll type http myapp.local/app/task in your browser. Step 2 will be this request is going to reach your Ingress controller, right? So the request enters the Kubernetes cluster. Remember, I already mentioned that Ingress will stay at the edge of your Kubernetes cluster, and this is the same thing they have mentioned here. This is very important. This is your cluster, this is your load balancer here, which is managed by Ingress, right? And this is where you're doing the browser is sending the request. So this is my browser sends request. It's go to my Ingress. This request will come through this load balancer. So this will reach Ingress controller. So what will happen? This request, whatever request, it enters your Kubernetes cluster through Ingress controller, something like Nginx, right? Now you think this one, let's say you are entering a city, and before entering a city you have a traffic police or something there at the edge of that city gate, right? They will check something, and then only they will let you enter the city, something like that. Once this is done, what will be the step 3? So step 3 will be very, very important. Ingress rules will be checked. Now what is rules? That I will just show you that there will be rules, right? That okay, when I'll go to my slash route, I want to call my front end service. When I'll go to slash API, I want to call my backend service. So this is where it will be checked, right? That if path equal to slash, go to front end service. If path equal to slash API, you go to backend service. Because user typed let's say http myapp.local/api/task, because it's a backend service call, so controller will forward that to backend service. Once it is forwarded, so what will be the 4th step, right? So this is going to service forwards to pods, to pod. Means your backend service knows which pods are running the backend service. Very, very important. Not service, backend containers. Sorry, my bad. This is important. So that is the reason, if you see, they have given service to pod here. So when service will go to pod, your backend service knows, right? So your backend service, so here you'll do, your backend service actually knows that which pod are running backend containers. How it will run? Via labels. Remember, I have added labels and everything in the YML file. So what will happen? It's going to load balance that request to one of the pods, whatever pods are currently available. The step 5 will be pods are going to handle that request, that whatever user is requesting, right? So that means you have your Node.js application, because this is a backend service that we are talking about. Your Node.js app inside that inside that pod process that request. So in this case the request will be what? /API/task, and whatever data it's going to do. For example, let's say for this one, what this will do, this is going to query your MongoDB. It's going to return a response back, the list of tasks, correct? So it's going to return back, and then step 6 will be response flows back. Flows back means whatever pods is going to return the response, it's going to back in a reverse direction. So it's going to go to response service, Ingress and browser, and then user is going to see the result in the browser. Means it's going like this. So you have your traffic, you have your browser, you have your Ingress, you have your service, you have your pod. Then what this is doing, pod is going to return the response, then right, and then it's come to service, then you do like this. Pod service, and then what will happen? It will come to Ingress, then it will come to browser, and you are going to see the result in your browser. So this is the whole process. Okay, so now I hope you will get a complete idea that what is Ingress, how this is working, and the complete process. And I think this is the easiest way I can explain, and I'm pretty sure if you watch this till part right now, next part whatever we are going to do, it will be like a very simple, like very simple I'll explain, right? Because Nginx also you have covered, right? But you need to understand all of this. Now think that if I don't explain all this, directly go and jump to practical implementation, how much difficult it will be for you to understand all of this, right? So now we are going to practically implement, but before that I want to explain one more thing which is very important. I again removed everything, all the images that we have created. Remember just now in the previous section when we have covered the configuration and the secret maps, we created a backend local, front-end local images, right? And then we have created the namespaces and everything, and then we have run all this command. You remember? I'm pretty sure you are able to recollect. Now the reason again I deleted everything, because I want to run everything again from scratch so that you can understand how this is working. If you haven't deleted, you can still do it, but I will suggest, so what you need to do, right? Everything will be available. So for you, namespace will be there, ConfigMap will be there, secret Mongo will be there, but we need to create the Ingress YML file, and then we are going to run the Ingress YML file. But if you want to learn this on scratch and more clean way, then I will suggest you just delete all the namespaces that you have created, delete the images, local images that you are having, and then you are good to go. The reason is, you will understand why this is important, because I deleted from the first to the end. We have to understand each and every command, that how this is happening, then only you'll be able to understand how we are going to run this on locally using our Ingress Nginx controller. So let's do that in the next part. Alright, so let's practically implement now. The first thing what we need to do, right? So we need to install Nginx Ingress controller. We are going to use Minikube for that, and the reason is because Minikube already has a built-in add-on for this. The first thing what you can do, again, I'm pretty sure you already deleted all the namespaces and everything that you have created. If you want to keep it, that's also fine. I'll also add all the resources that in case you haven't deleted, how you're going to do the extra changes based on that, the same process will work. But if you have deleted and do everything from clean, it will be easier for you to understand. The first thing what you're going to do, you're going to add add-ons that called Ingress, because you're going to use the Ingress Nginx Ingress controller. So what you need to do, right, you just have to do Minikube, and then you'll do add-ons, and here you have to give enable, and then here you have to give Ingress. That's it. This is the only change you need. Enter. Let's wait for some time. So what this is simply telling that, you are going to please install the Nginx Ingress controller in my cluster. That's it. Again, I already repeated, Ingress will sit at the edge of your Kubernetes cluster. That means you need to have that installed in your cluster, right? So add-on is now enabled. Now if you want to verify, what you have to do, you will do kubectl, right? And here what you need to do, you will do get pods and give -n and give name as Ingress, and you are going to do Nginx. And you can see that there will be a controller which will be in the running. So what simply this is telling, it is telling the namespace, which is simply Nginx, where the controller will live. This is the pod name, right? It's going to add a random suffix. You can see that here, right? And this is simply means that one container is running now properly, right? Status is running, and this is done. Now what you are going to do, if you want to inspect everything deployed, simply just do kube. Okay, let's clear this first. You do kubectl, and you're going to do get all -n, and you'll do Ingress Nginx, and you'll be getting all the details here, everything. Okay, Now what we are going to do, simply write the first thing, we need to write a ingress YML file, because ingress YML file will simply hold all the rules that we are going to configure. Remember, I already mentioned that it simply works as a router. Based on the rules it will provide, it's going to call the corresponding service, and service is going to call the corresponding pods. I already mentioned this point, right? If you go here, I already mentioned this point here. So now I already created this. I don't want to write everything, it will take a lot of time, but I'll explain each and every line what we are doing. The first thing, simply just create one more file here. So what I can do, right, we'll give 04, and let's give what we can do. We'll simply give ingress only, and then I'll do .yml. That's it. And here I have already created this one. Just copy this and then paste it here. Now I'll explain what this is doing. The first one, we have an API version. This is the API version. So this belongs to the networking API group in Kubernetes, and if you want to verify this one, just go here and you can see here. Okay, next we are having the kind. Remember, we have used the kind as deployment, services, config, secrets, blah blah, everything. So this is simply the kind as ingress, means we're simply declaring this object as an ingress resource. This is the metadata, this is the name, right? And then we are having the namespace, very important. This is the namespace that we are going to use, and then I added annotations here. This is actually optional, so I simply telling that if in case you have any kind of upload functionality and you want to increase your upload size limit, so you just set it here. I think this is also you can ignore. Then we have the spec. So first we have the ingress class name, which is Nginx. So this tells Kubernetes that we are going to use the Nginx ingress controller for this particular Nginx. If in case, again I repeat, if in case you have multiple controllers, this is going to choose the correct one or right one. Now we have the very important part, which is rules. Now this is where all the configuration will sits. The first of all, this is the host, right? So this is the domain name we are going to use. I'm going to use mon because we are using mon application demo.local. Okay, so this is the domain. Now we have some http.paths rule, right? So this is where the routing magic will happen. So what we are simply telling that whenever I will go to the path/API route, so we are going to send request to my backend service with this port, and then when I'll go to the path/route, which is the home route, I'm going to send request to my front end. Alright, so now after this, what we're going to do, right, we'll make one changes in my package.json, and we will allow not package.json in the server.js. So we will run on so in this port, so we'll do 0.0.0.0. so this is the first change. And second, what I'll do, right, we'll change one changes in my client side Docker file, and I'll explain what, although we haven't covered the multi-stage build feature, that will come in the next part for Docker section, but for now just remember what I'm doing, and it's not that much tricky to understand. I'll explain. The first thing, I'll go to my client side and go to my Docker file, and then I'll just comment the existing one. Let's comment this, and then I'm going to just paste it here. So what we're doing, we have actually two stage, one is build stage and one is run stage. What this build stage is doing, it's going to install the dependencies. First of all, it's going to build the front end, and also remember we are using this vit API URL with /API, and the reason is very simple, because in the Ingress the rules we have given that whenever I'll go to in this path, I need to call the backend service. So this is the reason that we have taken here. And then what this will do, this is going to produce a optimized file, and in the run stage we are simply start with a fresh image. Second, we are going to install whatever is needed only for serve. It's going to copy the built-in files, sorry, not built-in files, built files, and it's going to serve them. So this is actually doing nothing, but it's actually multi-stage build that we are creating. So in the stage 1, where it is actually building the stage, we are simply doing all the heavy lifting, means installing all the dependencies, compiling code, and bundling all the assets, right? So this is actually very important. And in the second stage, we are simply providing only what is needed to serve the static files. Now I know for some of you it will be tricky to understand because we haven't covered this, but again at the end this is doing nothing but simply copying all the files, it's installing dependencies, and then it's serving the static files. In the next part, when we are going to cover the multi-stage builds, it will be easy to understand. So for now, just copy paste this one in your Docker file, and in the server we are going to use this. Once we'll do that, now everything is ready. In our Ingress, the rules are also added. Now we will be running each and everything from step by step from scratch. So let's say how we are going to do that. The first thing I'm going to pin this one, let's do clear, because we need to do a lot of steps, right? First we are going to build our images locally. So now let's go here and let's start step by step. First I'm going to copy this and then I'll just paste it here, enter. Okay, clear. Now let's go here. We'll create the front end, but there will be one change. I will explain what. So paste it here. Now remember here, actually instead of this, what we need to do, right, we just going to call the /API endpoint, not with this localhost. Okay, this is very important, you need to do it. Okay, now hit enter. Okay, I again done some mistake. I need to give the tag here. So once we'll do that, what we'll do next step, we are going to add in or load these images in our Minikube. So let's start with the first one. Again, I'm doing all of this. I already told you multiple times, if you don't want to do all of this, what you need to do, you need to add these Docker file changes and then the server.js file changes. Build your front end image again, because we need to change the Vite API URL from localhost 5000/API to only /API, because that is the rule we have added in our Ingress. And then you can skip all these files, all these, right? Because but you need to again load it in your Minikube. So that is the reason I mentioned that you can delete all of this and do from scratch, so that you can understand that how this whole process is working. Okay, this is taking, okay, this is done now. Now let's copy this. Also you can see we have added this. We'll check once this is done. Okay, this is done. Now enter. So we have both. Now we are going to apply all of this step by step. First we are going to create our namespace. Again, these all are the same thing. So clear this. This is created. Now we'll create our config map. Okay, then create the secret. Remember, if you have given different name, just change this one, whatever you have added. Now once we'll do that, then we are going to run our Mongo. Now let's copy this, check if it is ready or not. Okay, now let's check, it should be running now. We check the pods, right? Okay, it's running. Now let's clear this. Now what we need to do, right, we are going to run the configured one, remember, because this is where we have the Mongo secrets and everything. And then what we are going to do, we'll check this one also. So let's see, copy this, and then we'll check the pods and the SVC. Okay, Now let's clear this, and then we'll do the same for front end. Okay, and then we'll do this one. Awesome. Now once we'll do that, now what we're going to do, right now we have a new YML that we have added for Ingress. This also we need to run. So what we'll do, we'll do kubectl, and I'm going to do simply apply -f, and then you have to go to the folder and then go to /4 -ingress.yml file, correct, enter, and this is created. Awesome. Now once this is created, now what we are going to do, right, simply we need to open a tunnel for Ingress. Now why we need this, I'm going to explain this one, but before that let's see if everything is created or not. So I'm going to just copy this and enter. Okay, you can see that everything is created. Now why actually you need it? So here what I'm going to do, I'm going to do minikube, and then I'm going to do this one as tunnel. What this will do, this is going to create a network bridge between your Windows machine or whatever machine that you are using, that is actually your localhost, and the Ingress controller, right? Now remember, the Ingress controller is running inside your Kubernetes cluster. Without this, what will happen, right? Traffic, whatever is coming, whenever you will go to man-demo.local, it will never reach your Nginx Ingress pod, right? So that is the reason what we are going to do. Here we are going to create a tunnel which is going to create a bridge between your machine or localhost and your Ingress controller. So now again you need to keep this one as open. So here I'm going to hit enter. Now let's see what is happening. So it's actually created, and see, you can see you don't have to close this one, right? Now let's open one more terminal, and here what we need to do, right, because sometimes if you try to go to your localhost and then not localhost in your browser and then try to access this mandemo.local, you will get an error, because what we need to do, right, in our machine we need to add this as a host entry with your administrative rights. And to do this one, to add this host, what we are going to do, simply you type here notepad, and I'm going to simply explain this one, and then do right click, run as administrator. Okay, and then do file and do open, and then you can see that I'm already in this. So here what you need to do, so you will give these paths, will do C, and here what I'm going to do, I'll go to this Windows, okay, then I'll do slash, and here I'm going to go to system32 slash, I'll go to drivers slash, and then I'm going to host. So in this path, click open, and you see you have all your everything is added here. What you need to do at the end, you just have to add this. So I'm going to add here 127.0.0.1. this is your localhost port, and here I will tell that, okay, whenever I'll go to this one demo.local, so I should be able to access this particular port, right? So this is actually mapped here. This is very, very important. So just save this and close this one, and now what we need to do, right, simply just copy this, or let's go here, okay, let's do here. So we'll do HTTP, right, and here you just have to paste it, and then if I just copy this and let's go here and see what is happening. Awesome, right? Now actually Ingress is handling all this. So this is work as an entry, and then it's going to create a bridge between your localhost and your Kubernetes cluster. Whenever you have your Kubernetes cluster, this request is coming, then it's going to the Ingress Nginx controller. Nginx controller is going to call the Ingress. Ingress will check all the rules that you have added here. For example, if I go to /API, it is going to call the backend service. When I go to /, it's going to call the front-end service. And if you go to network tab, refresh this page, you see what it is calling. It is actually calling this URL. And even if you add this is going to work. Okay, create this, and you can see this is working. Refresh this, the data is there. So this is how exactly you need to do it. Now this is a lot of process. Now I will say this is not only all the features that we have covered, there is still a lot of advanced topic is there. But if you're a beginner, I will not say this is a beginner concept in Kubernetes. First of all, this is the intermediate level of concept. This is more than enough to get started. Now in the next section, in the next part, when I'm going to go into much advanced level of concept, then we're going to take leverage of some of the things that we've learned so far. So that is the reason I'm doing this on incrementally, right? So it will be easier to understand. What I'll suggest right now, what you should do, right? You should create a new namespace and then try to create each and every command that we have used so far and try to experiment. Then only you'll be able to understand these things very, very easily. So that's all for this particular section. Alright everyone, so now we are going to finish this particular video with our last section, which we are going to cover in this particular section, storage and persistence in Kubernetes. Now first I'll give you some of the background. Now this will be little short section, but it's actually very, very important. Now if you go to your mongo.yml file, right, and you'll see here one thing, that where we have actually declared the volumes, we have an empty directory here, right? And this is empty. Now what actually this means? So this is like it's like a temporary notebook. You think like that, right? So that means as long the pod will be there, the data is there. So something like, let's say as long as student is there in a class, the notebook is there, something like that. The moment pod restart or it crash, your data will be gone. I hope you're getting. So now, but this should not happen, right? Because there can be possibility that your pod you are going to restart a particular pod or it might crash. But if in that case your data is gone, it is a huge problem, especially in a prod application, right? So that means whenever your Mongo pod, so in this case here, if it is deleted or rescheduled, the data will be lost. So here we need some kind of storage mechanism, right? Similarly, we have understood the concept of Docker storage, right? So here, how we are going to do that? So in Kubernetes, actually separates or computes pod from storage. Now, I already mentioned this point multiple times, I think more than 10-20 times, that pods are actually can die, restart or move to another node anytime. But whenever you have any kind of storage or data, it has to be persistent, right? That means data should, so if I go here, right, so I'll just write this point, that data should survive or data must survive, I will say, even if your pod restarts, even if pod restarts. Okay, so this is actually very, very important. So here to solve this, what we are going to do, right, we are going to use something called persistent volume. Now if you go to the official documentation, and you will be getting a whole lot of information here, and each and everything is very mentioned in very detailed way. But obviously we are not going to cover each and everything. I actually learn all the concepts from here, and whatever things I'm going to pick for a beginner, that is more than enough. Now let's understand what actually is persistence volume, or PV in short, right? So here let's write it here. So we'll do persistent volume. So actually here this V will be caps and this P will be caps. Okay, so here this is called short as PV. So this, you think it's like a chunk, it's like a chunk of the actual storage that you are going to have. Okay, this is the chunk of the actual storage in the cluster, right, in your Kubernetes cluster. So here it can be your disk, it can be cloud volumes, etc. Right? Now if I want to explain this one in a very simple way, so just like I have given the example, let's say you have your notebook and your student, as soon as your student will be there, your notebook is there. As soon as the student leaves, your notebook leaves. But let's say in that particular school you have something called as locker. I hope you're getting. And in this locker you can keep your notebook. So it's like simply exact like that. So you have some place where your storage sits, right? So even if your pods dies, your storage will be there, still it will be there. Means if I wanted to explain this one, what this locker means, this is simply independent of pods. right? Very important. Then we have something called persistent volume claim. Now you can search all of this. If I search here, right, persistent volume claim. So this is in short called PVC. So this is a request for storage by a user. Okay, so let me just copy from here. So I'll copy this. So this is in short called PVC. So this is a storage that actually requests by a pod for storage. Okay, so it's simply like, okay, you have one student and that student is saying, okay, I need a locker with this many space, that I need a locker with 1 GB storage. So that means you are actually demanding, so something like that, right? So this is where your user actually requesting the storage, that I need this much storage, right? And here what will happen, Kubernetes is going to match the request to the available lockers, means here in this. So PVC is going to check if there are any available lockers or not. So it's like a persistent volume, so it will check here. So that means here is the actual storage that is available in the cluster, and PVC is the request that is made by the user, and then Kubernetes will go here and it will check if that storage is present or not. See, I don't know if I'm able to explain this on much simpler way. This is the most simplest way I can explain. Now why, now again interview questions, this can come like why this matters. Very simple answer, that whenever you're going to have any real products and application, you cannot have this kind of situation where you have pods and you restart a particular pod, or you delete a pod, your pod crashes and your data will be gone. Absolutely no, right? It should not happen. So data persistence is very mandatory. Databases should not or cannot lose data. What does PVC ensures, right? So this is going to ensure that data is not tied to pod lifecycle. So this is also very important. So PVC is going to ensure that, so it is going to ensure that data is not tied to pod lifecycle. Okay, so now let's see how we are going to do that. The first thing, if I will show you a very simple way. Okay, so first what I'll do, right, so if I go here and I'm going to refresh this, so I have this data. Now if I just simply go here, open another terminal, and what I'll do, right, I'm going to remove my current Mongo pod. So my pod will be getting deleted. So what I'll do, right, I'll do kubectl. See, these things are very important. So I'll do kubectl, I'll do -n. Then what I need to do, I need to give the name of the namespace, which is DevOps part 3. If you have given different name, you just add it, that DevOps part 3. And here what I'm going to do, I'll do delete, and then I'll do pod, and here I'm going to give the label, which will be, what is the label? So label is app equal to Mongo. Okay, and hit enter. This will take some time. Let's, okay, this is done. So now what I'm going to do, I'll do kubectl, okay, and I'll do -n. So I'll do DevOps part 3, and let's check the pods. Okay, so I'll do get pods, and I'll do -w. So you can see that it's not running. Now I will go here and I'm going to refresh the page. See, the data is not there. So this is what I mentioned, that whenever you have, if you are not managing the storage separately, if your pod crashes, your data will be gone. So there is no way you can recover this data, and this is very bad, right? So when you have production level application, this should not happen. So here we need to introduce something called as PVC, and I already mentioned PVC is the actual data that is requested by the user, and then Kubernetes is going to check in the persistent volume in the PV where the actual chunk of data is there, that if that data matches, based on that it's going to provide you that particular storage. So what I'm going to do, I'll go here and let's do one thing here. I'm going to create one more file. So what we can do, right, maybe let's give this one as Mongo PVC, or let's do Mongo PVC only, and I will do YML. Okay, and what I'm going to do, right, so I already added this here so that it will save some time, and it's actually very easy to understand. So the most important part here you need to check, that is the kind. So we are actually using the kind as persistent volume claim. This is the metadata and some spec we have added here. Now remember one very important point, whatever name you are given in the metadata, that is actually important, and the namespace also should match. Kind is also important. So you are using a PVC, right? So this is the kind that you need to use. If I copy this, right, you can also search here in the official doc. See, so this is the kind that you need to use. So now this is done. Now this is completed? Not yet. Why? Because now we need to go to our MongoYML, and this empty directory we need to replace. Okay, this is very important. You need to remove this. And what we are going to do, right, we are going to simply use a persistent volume claim, and the claim name I'm going to give the name of the claim. So name of the claim is nothing but this name, and then I'll go here, let's copy this. Okay, and then I will go here and I'll remove this, save this, and save here, and this is done. So now what I'll do simply, so this is completed. So first we need to apply this config. We need to start our Mongo deployment, and we are going to restart that, and then we are going to check the status. Okay, so let's do step by step. First I will close this, let's clear it. So first I'm going to do kubectl, and I'm going to do apply -f, and then we need to go to the folder, and / what I'll do, I'll give the name which is Mongo PVC. So I'll do Mongo -pvc.yml, enter. So this is okay, I think I've used this one, so this is already unchanged, it's there. So now what I'm going to do, so I'll clear this one, and then I'm going to apply this one. So kubectl, and I'll do apply -f, we'll do k18s, and here I'm going to give this one as 01 mongo.yml, enter. Okay, so this is configured, so you can see that. Now once this is done, now what I'm going to do, I'll do clear, I'll do kubectl -n, we'll do DevOps part 3. So this is the namespace. I'll do a rollout. Now remember, rollout and everything, I will explain this one, that what are the things we're going to cover in the next. So we'll explain this one in details. For now we are just doing a rollout and restart, and we're going to restart the deploy /mongo, enter. So this is restarted, and then I'm going to do kubectl -n DevOps part 3, and then I'm going to do check the rollout status, and here we are going to do deploy /mongo. So there can be some old replicas might be in termination, it's in progress, so in that case you have to wait. So now this is done, so now clear this, and then I'm going to do kubectl, and what I'll do -n, I'll do DevOps part 3, and I'm going to do get PVC, enter. So you can see that you will be able to see this bound here, right? So this is mean this is actually active. Alright, so now let's see what is happening, right? So we'll go here, and then I'll just add a task, and let's give this one as new data added after PVC, something like that, and then I'll do create. So this is added. So now what you can do, right? So how you are going to check it? Now refresh, the task is already exist. So I'll go here, and then I'm going to delete the Mongo pod again. So I'll do kubectl, and I'm going to do -n, I'll do DevOps part 3, and here what I'm going to do, I'll do delete pod, and then what I'll do, I'll do L level, and then I'm going to give this one as app equal to Mongo, enter. So this is deleted. Now if I go here and refresh this, see, the data is still present. So this is very important concept, right? So even you deleted the data, even if the pod is getting deleted for that Mongo pod, even your data is still persisting here. So this is the concept. That means you are now showing your showing persistence using PVC concept. Now there are definitely a lot of things are there. It's not possible to cover everything, and even if I cover everything, it will make your mind little you will understand, okay, what is happening here. There are a lot of things. So that is the reason I've whatever I've decided that, okay, these are the things I'm going to cover. I think quite a few times that, okay, this is how I'm going to cover each and everything. You will also understand that this is Kubernetes is not a simple things to understand, right? Even if you go to the official documentation, there are a lot of things are there. You can't even complete this only Kubernetes in 10 parts, right? Still the video will be there. Means even if I try to complete each and every concept in a 10 parts video, right, I will not be able to complete this one. So a lot of things are there, but the basic things, what actually this persistent is, how it is working, I hope this will make the concepts clear for you. Okay, so with this we have completed the part 3. Whatever we have covered. Now coming to what are the next parts. So I've already covered, added some of the things. I just wanted to quickly mention. So I'll just copy this from here, okay, and you'll understand that what are the things you're going to cover. And I'll just add it here only. Let's add it here. I'll just show you that what is happening here. So first, in the next part, we are going to cover the resource request auto scaling. Okay, so I added the section. Then we are going to cover this reliability, access control, intro to Helm. This is also a very important concept. I don't know how to pronounce this one. I think it's called Helm, something like that. And then monitoring and logging. This is very, very important. I think there will be a complete separate section with this monitoring and logging, because we are also going to cover Prometheus Grafana, and also how we are going to implement Helm charts. Then also how we are going to log with EFK, Slack, Elasticsearch, then you have Kibana, these kind of things. A lot of things are there. I am also not sure how many parts will be there. Okay, I am also a little confused, so I have to now think and then redesign. But you just make sure that these all the things will be coming in the coming parts. Okay, so Kubernetes is not yet completed. There will be more parts will be coming. So with this we have completed our part 3. So that's all for this particular video. I'll see you in my next video. Till then, good luck and peace.